Good morning. Welcome to the second day of our compost workshops. This is improving stormwater quality with compost, and we've got a great lineup for you today. Welcome to the second day of compost workshops. Oops, let me back up on the slide, sorry. This is improving stormwater quality with compost, and we've got a great lineup for you today. Apologize about the little glitch there. Good morning, everybody. And my name is Jack Broadbent. I'm with Caltrans, supervising landscape architect. And today we're going to go through day 2 of improving roadside vegetation and stormwater quality with compost BMPs. We got a great lineup, and today is more on practical applications of compost. So we've got 3 different individuals from Caltrans, Jim Phillips, Scott Dallin, and Jeff Petersak, who will talk about some of our projects at California Department of Transportation. And then Sally Brown from University of Washington will cover some topics with compost, and she's an expert with soils for salmon. And then we have Compost Around the World with John McCullough. John McCullough has been, I would say, a partner of mine for probably 20 years or so, working on erosion control, and I can say one of the experts in the nation on erosion control, along with the other presenters we have. So with that, after all of the presentations, we've got a panel of all the presenters that were with us yesterday and today. And we've got about a half hour to review some of the bigger questions that come in, and we'll have those posed to the panel and have basically an open discussion. If you see on the screen, you can email your questions to compostworkshop@dot.ca.gov. I've got a whole team of expert people that are pulling your questions together and feeding them up to our host on the questions, the Q&A session, Ron Alexander. So with that, I'd like to pass it over to Brian Larimore, my counterpart at Cal Recycle, and we will start the presentations. Thank you.
Thank you, Jack. Our first speaker, Jim Phillip, has experience as an environmental engineer, hydraulics and hydrology expert, roadway designer, and construction inspector over a span of 25 years. Jim assists Caltrans roadway designers in the installation of permanent stormwater treatment methods for highway projects. Jim is going to discuss compost use as an amending agent in some of Caltrans stormwater treatment tools to enhance infiltration and natural treatments. Jim?
All right. Well, good morning and welcome to day 2. My name is Jim Phillip, and today I'm going to give a presentation on the use of compost and stormwater treatment BMPs. Next slide. The ones I will be covering deal specifically with runoff from paved or impervious surfaces. So we use compost amending in soil to accomplish 3 primary benefits. 1, pollution control for the designed storm volume or flow. Number 2, runoff volume control. And then 3, for compliance with our NPDES permit. So on this slide, we're looking at so we're also going to, at the end of this a couple slides here, I'm going to give you just a couple of examples of these types of treatments in the field. So we'll have that to look at. So this figure on this slide is a cross-sectional view of what we call typical design pollution prevention infiltration area, or we give it the acronym DPPIA for short. We always attempt to infiltrate first as far as the pecking order of available treatment strategies. So infiltration is number 1. At a minimum, we like to treat the design storm volume, which will vary on treatment area and the location of the site within the state. We try to do this as close to the pavement as possible in keeping with low impact development strategies, or LID. Everyone's kind of familiar with that. All right, so next slide. And those lengths that I show on there are just kind of like example lengths. I mean, that's going to vary. Lengths and depths will vary. And also on this slide, too, I give some dimensions, but it'll really depend on the designer and what they end up needing to treat for. So here on this slide are the 4 primary stormwater treatment tools that use compost as part of their makeup. The 4 are DPPIAs, bioretention basins, infiltration basins, and infiltration trenches. The first and easiest way for designers to turn water runoff off the paved surface is to amend the soil with compost, creating a DPPIA. The compost provides voids in the soil for water and may also increase the rate of infiltration of the native soil. Also, any grasses or plants that can also be planted on top of the treatment area. The treatment mechanism of the design storm is by holding and infiltrating and/or absorbing nutrients or filtering other constituents in the stormwater. This is accomplished by mixing compost into the soil at a specific ratio and a prescribed depth. Another more complicated method that uses compost is bioretention, which can also include both infiltration, absorption, filtration as primary treatment methods. Then there are the 2 larger volume methods of infiltration, the infiltration basin and the infiltration trench. These both provide a large volume capacity for the design storm. Next slide, please. So these next 2 slides, I'm going to look at 2 locations, actually 3 locations, where these methods were installed to promote infiltration and natural biological treatment. This first location here shown is a park and ride in Central Valley where an infiltration trench was installed and planted with shrubs and trees. You can see a curb opening in the foreground of this picture that encourages water to enter from the side, and this combines then with the water that sheet flows in from the parking rows. Okay, click this once because I have one drop in, I think. Yeah, so this is it after it's been somewhat established, already planted and then growing. So next slide. And a little trench. Yep, so the trench is underneath all the grass there. Okay, so this last slide shows the application of bioretention in an urbanized or city environment. Typically in urbanized city locations, room is at a premium, but Caltrans and other cities and counties have been very successful in installing these as stormwater treatments, as they have also been used throughout the country. These 2 locations are in the San Francisco Bay Area and are both bioretention systems. Treatment here would be by infiltration, filtration, and biological treatment, as well as providing trash capture. All right, that concludes my presentation, and I can entertain any questions now.
Okay, Jim, thank you for that. This is Ron. I was obviously passed out there. I apologize. I have a question that actually came in last night, and it was directed for you. And the question is, the Stormwater headquarters has a new spec for compost to use in treatment BMPs. How are these going to transition to use a new spec with compost application for biofiltration strips, DPPIAs, and biofiltration swales?
So any kind of new spec that comes along, so I'm not familiar with exactly what that may be, but we work really closely with landscape architects. So they own the compost spec, and then we just reference that into our specs. So for the treatment of any of these, or the think of any of these treatments that would include compost, we just then refer to Section 21 of our standard specs that has the compost requirements in that. And I mean, I'm not sure what that may be as far as a change of that. Whatever they end up changing, we're good with that, and we'll just use whatever they specify in their section as the amending agent then for the specific treatment.
Okay, and then somebody asked the question, could you repeat what the acronym DPPIA stands for?
Yeah, so it's Design, Pollution, Prevention, Infiltration Area, or DPPIA. So
Great.
basically, it's simply just an infiltration area. So we give it that acronym, so designers have something to call it, and it's they're real easy to install. Typically, we try to do them like 3 feet off the paved surface. I mean, it'll vary by location in the state, but we try to do them very close to the pavement. They're real easy to install. So yeah, they're good. They're a good treatment.
And let me ask you this: do we have any history as of this point on how soon the filtration systems, the media, has to be replaced?
We don't have, like, as far as a typical service life for one of these. I mean, it would kind of vary
Sure.
by location. I mean, how much sediment loading might be coming into it, and but right now, I think we're giving it about a 15-year service life.
Right, right. I have a question personally. Have you guys been involved with actually measuring pollutant removal from water coming in to water leaving the feature yet?
Yeah, we have. We've done that. I mean, this goes back 20 years actually. Down in LA is when we actually first started doing these treatments and the testing of them. So water in, water out. Us as well as others. Texas has done a lot of testing, and we've hooked up with them for a lot of the data. There was a whole statewide testing protocol that was done. I'm trying to think of the year that was done, but yeah, these have been really nationwide. These are this type of treatment is used, and we have we have a lot of documentation on those, and so. Yeah, these are very effective. Yep.
Yeah, somebody just asked the question, is there any new evidence based on the effective developments in biofiltration and bioswales and strips? I kind of think that work is being done ongoing on.
Yes. Yeah, and I know, I'm trying to think of who's doing, there's a group. There's actually, in the state of California, there's a group that has compiled all these. It's somewhere down south. One of the universities I know has been looking at this, and they continue to. I don't know if it's a group affiliated with CASQA, which is our stormwater NGO that kind of provides a clearinghouse for a lot of technologies and treatments and things like that. So, yeah, you're right. There's a lot of ongoing. We continue to document, I think, the effectiveness of these treatments as we go forward.
Okay, there was a question that came up about desert compatible compost. A question was asked yesterday. We're going to get to that later in the day when there's a more appropriate time for it. There's a question, I'm not sure I totally understand it, but how are the problems of saturating local utility corridors handled?
Saturating local utility corridors.
Okay.
I'm not sure what that may be.
Okay.
I mean, we typically will put utilities within a right-of-way. Typically, they're overhead, but if they go underground, and we try to be careful as far as the placement of these and the depths of these. I mean, our main concern is the roadway and its foundation. So we try not to put these deep and close to the paved area because we don't want to start saturating the subgrade and then start having the pavement move around. So, but that's usually not a big concern. I mean, if it is, again, we'll put geomembrane or something in to keep the water from getting underneath the road if it's super close to it. So there's ways around it. But as far as utilities, I haven't seen anything on that. Other utility conflicts, maybe.
Okay. Have you is there any special practices you're putting into place for maintenance of the different features?
We provide, so we have design guides for the designers that tell them or encourage them to have certain features in place for the maintaining of the different treatment BMPs. And then there's also maintenance, or California Caltrans Maintenance also has a handbook that the field crews use in maintaining all the various treatment BMPs that we have available. So yeah, we have pretty good documentation on both on the designing of these and making sure things are in place when they're built, and then after they've been put in place for the maintenance crews because yeah, these have to be inspected at least annually. So yeah, there's that requirement for their whole life as far as maintaining them. So yeah, we have pretty good help, I think, for the people who have to watch them.
Okay. There was another question that came in about tacking compost on slopes. We'll go over that later on too. That question was answered yesterday, or was asked yesterday. It'll be brought back up later on. Final question though, for you, Jim. Does Caltrans salt the roads, and how are you handling road salt buildup, toxicity in the vegetated DPPIAs?
I don't know specifically. I know we've changed to a brine now used up in the hills. But they still do have salt houses and that. So, yeah, I don't know that we've looked at that specifically in detail.
Okay.
So yeah.
Well, I think later in the day we'll bring that back up, because I know Britt and I had to deal with that in a very cold area in Canada. So we'll talk about that again later. Jim, thanks for that, and a great presentation. Thanks for answering all the questions. And Brian, I'll pass it over. Can't hear you, Brian.
Oh, okay. Thank you. Our next speaker, John McCullough, is a watershed geologist, geomorphologist, a certified professional in erosion and sediment control since 1986, and California landscape contractor for 20 years. Also a California Community College instructor teaching erosion control and watershed management at Shasta College for 22 years. John owns and operates Salix Applied Earth Care, Salix, a consulting firm located in Redding, California, practicing in the fields of erosion and sediment control, watershed restoration, stream restoration, and biotechnical erosion control. He is the project manager for the Shasta College Erosion Control Training Facility, a 6-acre site built to replicate construction site conditions in order to research and demonstrate the proper use of BMPs. For over 6 years, John was the co-instructor for field erosion control BMPs on Caltrans construction sites, 2-day field courses provided to personnel at each Caltrans district. He also was on the development team and instructor for training on sustainable erosion control on Caltrans sites. John will discuss case studies on applications and use of compost on various projects from California to Alaska to New Zealand and to the Canadian Rockies, spanning 15 years. John?
Thank you, Brian. Thank you, Brian, and thank you everybody for showing up. I'm very honored to be able to present today. I'm going to talk about a couple of things. A lot of it is going to be practical applications of compost over the last 20 years. Before I go there, I just want to mention, while Jim Phillips' presentation is hot on our minds, I really want to highlight that concept of the DPPIA. Not talking about bioswales or sediment ponds, or just that concept. Think of Caltrans right-of-way, the total right-of-way. Now take away the recovery zone. So we have Caltrans owns a right-of-way on the side of the highway. Take away the recovery zone. There's opportunities for a lot of that right-of-way to be turned into an enhanced infiltration rate. So I'm going to show you in my study that there's some trials we've done that show by compost incorporate we can increase infiltration rates to accept the 10-year return interval storm for the area. So just imagine the opportunities there that exist along the right-of-way. One of the things we mentioned, the sustainable erosion control courses that Jack and his division presented earlier in the decade, there was a concern about on the highway right-of-way, just general construction standards and construction. The contractors and the machine operators leave the soil compacted to 95, 98%, just as a natural course of things. And now we're mentioning, well, we have this DPPIA, and how safe would it be to decompact those right-of-way areas and actually add compost to it? And so Jack invited a lot of the geotechnical engineers from Caltrans to help us look at those right-of-ways. And just to mention the obvious, soils that stand at 2 to 1 are stable, and so maybe 2 to 1 or less. So you don't necessarily call a geotech engineer unless it's steeper than 2 to 1. So we have a lot of soils, a lot of right-of-ways that are 3 to 1, 4 to 1 that could be modified with compost. That DPPIA, let's just keep that in mind today. Well, here's a video that shows examples of some of the things we're talking about. We need the audio. Pause that a minute, Jack. The audio is not coming through. Hang on, it's coming up.
We need to do surface stabilization treatments for raindrop impact, and we either use straw mulch, or we use erosion control blankets, or we use compost. Compost seems to make the most sense up here. We have a seed mix already in the compost, so by next spring, the grasses will be growing up between the compost. The compost will still continue to provide raindrop impact erosion protection. Just a win-win situation.
Pardon the little glitch there. We all have that. It's just
virtually this site is done. So I know all you viewers out there have just been dying to see how the Pembina River looks up here on the Hinton project. So here we are up at the Pembina after 1 year, and boy, it's looking good right now. Compost turned out really nice. Built a nice soil. That reclamation blend is done nice. So here's the compost blanket after a year. It's been through a big winter freeze, spring rains, and it's done really well. This grass blend has done well. Again, they're well rooted in there. These grasses, I can't even begin to pull them out, so there's no way that this thing would erode anymore. It gave us, the compost blanket gave us 99% coverage for erosion control, and it also provided a nice substrate for grasses to grow. I mean, look at this compared to other areas, adjacent areas. So again, compost is just really a nice erosion control practice, especially when you have one of those blower machines. Now the compost sock here really did its job too. This thing, it took quite a beating. You can see here where a semi with dualies drove over it, but it didn't break. It's really entrenched into the soil. There's just no way I can move this. So these roots have gone down in through here and locked into the soil. It's still viable after a year. This stuff is still relatively strong. The reason we put the the compost berm and the compost socks here is because we needed most of the erosion and sediments coming off the road and flowing this way. So what we wanted to do is make sure there was some kind of sediment control between the river and the source of sediment. So normally this is when we'd use a sediment control BMP. Silt fence would be put in typically on a construction site, but the silt fences, they get driven over, they get knocked down, they're not maintained, and they're very difficult to install properly. So we wanted to look at an alternative to silt fence here. And we see this has kind of been a permanent BMP. This berm is here, it's protecting the river from any sediment coming off of the road. And then we also have a nice compost and vegetated buffer for secondary and tertiary treatment. I doubt very much if any sediment came off of the road and got into the river here. And the other BMP we use that's really neat is the compost berm. Remember, we put this compost berm down without the sock. This went down with just that plate that was pulled along and laid this compost berm. So this compost berm does the same job as the sock. There was some concern that it might not be sturdy enough to last. Well, it's lasted just fine. Again, the vegetation has grown within it here, and you can see the deep mat of roots that has now locked in this compost berm. So here you have vegetation well established. Every one of those roots were holding that berm together and providing revegetation. You would have had to come back 3 or 4 times during a winter to maintain a silt fence in this condition so that it would have operated. You can see sediment has built up here from the storm events. Sediment has built up and not gone into the river. All in all, I give us a really good scorecard here.
All right, thank you, Jack. Jack's going to turn this onto a group viewing. I just want to mention that video was done up in the Canadian Rockies in 2006 and 2007. We did a bunch of stream restoration projects for the Calgary or the Alberta Department of Transportation. And that's some of the things we learned. So I want to mention a little bit about some of the problems that we might treat with compost. And I want to mention hydromodification. It's a systemic problem from urbanization. The bottom line is our urban streams are downcutting in adjustment to new flow. And this is before awareness of our climate change. Just urbanization, lower infiltration rates, impermeable surfaces are causing our streams to downcut in size. The photograph on the left shows a stream in Austin, Texas, the most flood-prone city in the nation, they say, because of the caliche soils. But if you look, they run their sewer lines down the stream. That one sewer line had to be abandoned as incision. They had to put in a second sewer line on the left of that. And it's almost time to replace the third sewer line over on the left. So this is the condition of hydromodifications. Next, Jack. Our Center for Watershed Protection has done a lot of analysis of stream bank. You can see on the picture on the left, that was determined. You're looking at the stream and the fellow's looking at it. They surveyed some of these streams that's showing incision like this and correlated it. This is correlated to 20% impervious cover in the watershed. You talk about build out in urban watersheds. The picture on the right shows a stream that I've been working in, and we did calculate that there's been over 20% impervious cover, and it's being reflected in the drainage. We have hydrologic impacts with roads. When I went to college in watershed restoration, we saw paired watershed studies with watersheds that had roads, timber roads, and watersheds that didn't have. And there was a 55% change in hydrology with watersheds that had roads. So roads are also causing hydromodification. Of course, we're talking about the highway department also. We're altering hydrology. Next, Jack. And then I want to mention something that's, you know, some of our brittle landscapes where we have range land activities for over 150 years. Many places in California was kind of brittle savanna type environments. There was sheep brought in the 1840s, 1830s. We had 60 years of grazing by sheep before the cattle were ever brought in, then 150 years of cattle grazing. We've ended up with an environment where the cattle and sheep have compacted the soil. They've actually changed the vegetation. These soils used to be covered in this particular area with Nacella pulchra, a purple needlegrass that had roots 6 feet deep. And those roots would hold the soil open. There was infiltration rates of over 2 inches an hour historically, I mean, for centuries. But what's happening now is it's in the tenths of an inch an hour. We have a cow pan, and all the water, all the rain that hits the land turns into runoff, and the streams are incising, just like urban streams. Next. And that turns into gullies and water quality problems. Next. And here's an example of a 6th-generation cattle ranch up in Shasta County. It's typical to many. A lot of these brittle environments, the streams are reflecting the amount of hydromodification that's going on in the land. Next. So streams, urban streams, wildland streams are showing, they're an accurate way of reflecting the amount of hydromodification that's going on. This is a stream down in the Santa Clara Valley. You can see the incision. Next. So why am I mentioning this? This hydromodification is such a large problem that the Clean Water Act and the NPDES has required looking at post-construction BMPs. Post-construction BMPs basically mean let's stop the incision of our urban streams. Let's infiltrate the water. Let's get it back where it used to go. And put back the hydrograph. So can we do that with soil amelioration? Can compost help us with that? Is why I'm spending some time on this. Next. So we want to maybe decompact the soils, ameliorate, add compost, reduce the bulk density, put in a plant, a native biomimicry, put in the native grasses that had those deep roots. And maybe at the same time, we're doing carbon sequestration and we're reducing hydromodification. As my college professor in natural resources pointed out, compost and organic matter is probably the panacea for all of human problems. Next. One of the things I want to mention is, for instance, Nacella, purple needlegrass, California state grass, is a mycorrhizal grass. So what happens is those 6 foot of roots that grow down, they also have a relationship with mycorrhizal fungi. That fungi will actually grow right into the root of the grass, and then they send out hyphae and pull in moisture, they pull in phosphorus, nutrients, and they help feed their host plant. They love their host plant. The host plant provides the carbohydrates for them, and at the same time, the mycorrhizae protects the host plant from desiccation. Mycorrhizae, arbuscular mycorrhizae, actually has one that's a glomalus, and it sends out glomalin, which actually coats the roots of the host plant and reduces them from desiccating. This black humic type substance also helps the soil aggregate. So can you imagine this Nacella lives 80 to 200 years, just one plant. And the rangeland in California was dominated by this grass. Needless to say, there was no runoff or hydromodification in the past. Next. But we have to actually have the mycorrhizae in the soil. One of the things I talked to Professor Elaine Ingham with the Soil Food Web, and she pointed out that yes, it's true that the composting, the hydrophilic activities of heating up the compost pile actually kills the fungi. So when good compost is produced, it lacks fungi. Now that's not a problem. We put the compost on a soil, and the soil, chances are, it might have fungi in it already. But Elaine Ingham points out that fungi is very delicate. It doesn't like to be damaged. Yes, in fact, those brittle soils I was showing you in the rangeland, that fungi has been removed. When the grasses were removed, the fungi had nowhere to live. These fungi are transmitted through the soil. They're not airborne. So once you remove the host plant, within 2 years, all the fungi and the propagules are gone. If we go back into these areas and try to plant the native grasses, they're not going to do very well. In fact, the non-native grasses are going to have a leg up because they love fertilizer, they love chemical fertilizers, they love ignored areas, they love highway right-of-ways. We actually have to add fungi back with our native grasses when we're in soils that are depleted of mycorrhizal fungi. So just keep that in mind. Elaine points out that the fungi don't even like to go through the gut of a worm. They get upset going through the worm's digestive system. So it's a little more critical than we thought. Next, Jack. Compost is effective BMP. Let's look at that. Next, Jack. Soil erosion laboratory, this is what it looks like, this test bed. We got some of the results of that already. Compost was tested on the bed, and it was rained on it. All these erosion control practices were rained on with deionized water, a state-of-the-art. It was a 10-year return interval storm that was used for the LA basin, which is like 2 3/4 inches an hour, and replicated 12 times. Next. From that information, next, Jack. From that information, we got some effectiveness. And I want to point out really quick, next, Jack, that straw mulch was determined to be 90 to 95% effective. Wood fiber mulch was 50 to 60% effective. Bonded fiber matrix, look at that, 90 to 95. Nowadays, with the new BFMs and like the products like Flexterra, we easily get 96, 97% effectiveness with those things. Next, Jack. And then the erosion control blankets are, again, in the category of 90% effective. And next, Jack. And then we found that compost blankets, yes, next, are actually 99% effective. So the takeaway point I want to make is we have 4 most effective that are greater than 90% effective erosion control BMPs. These are land cover BMPs that prevent raindrop impact. If you're going to choose a BMP for erosion control, why don't you pick one of these 4? And that's the takeaway message. We have 4. Why would you pick BFM over rolled erosion control blankets? Well, maybe blankets are difficult to install. They take a lot of labor. Maybe a BFM that you spray hydraulically would be much easier to install. So anyway, all of these BMPs have to be installed and installed effectively. So now a lot of the BMPs is the devil in the details. How do you actually install them? Next. That's a story for another presentation. But I want to, when the compost was tested at San Diego State University, they did use a tackifier. This is a proprietary product called Microblend. Rexius put this out back in the 10, 20 years. A lot of the studies done in Texas use Microblend. So you mix this Microblend, which has organic matter in it, maybe food for the fungi, food for the bacteria, like cornstarch, tackifier, maybe like guar gum, and you mix it into your compost and you have the tackifier right in with it. I think we need to relook at this. Contractors may not like it, but this is going to produce the most effective compost applications for erosion control. Next. Turf reinforcement mats are used, and we could actually, what we've done is we've underneath the turf reinforcement mats, and this grass in the middle is only 4 months old. That's a Bromus carinatus, a California native. So with the mats and the roots, we could actually do drainage swales, and they can withstand maybe 18, 20 feet per second, and we could have compost underneath this because the mats will protect for the velocities. Next. I want to give a couple of case studies now. This is the Palisades Trail. It's here's the Sundial Bridge in Redding. Looking west is pretty smoky right now. But this trail is off Highway 44 and the Highway 5 junction. Next. We were fortunate to cut a trail up through that right away. You can see it's an old alluvial deposit, has clays and gravels. Upper end is all clay, thick clay soils. Drainage is very bad. Once they made the cut, we ended up with these sapping erosion, not raindrop erosion, but sapping coming through and pulling the clay particles and soil particles with it. We actually had to put geogrid underneath the trail. Next. And you can see that the trail was primarily non-native grasses and star thistle. So there's what the trail looked like when we went in and tried to develop a fix for it. Next. So the idea was to use the Inca mat, remember, and there's the trail tread right in the middle with the red arrow to it. And there had been so much erosion, we packed the little mini gullies with a compost soil mix, wrapped it in the Inca mat, and then used 2-foot long pins to anchor it into the soil. We wanted to, because the water pressure, pore pressure is sapping the products out, the Inca mat and the pins form resistive forces pushing back in. But that's not the long-term solution. Will be to vegetate that with Nacella pulchra, for instance. Get those 6-foot roots in there. So the way we did that, we packed on the cut especially, we packed the cut with 2 inches of compost. We mixed guar gum with it, packed it in by hand, then covered it with the Inca mat. So we have a 2-inch layer of compost mixed into a mix like a mortar and slammed onto that cut and then put the Inca mat on it. Next. And you can see we use the CCCs. We were mixing guar gum at 60 pounds per acre. And then sticking it on. Next. So you can see here where we stuck it and wrapped it and then the long pins going in. Next. So it's coming along pretty well. It took us a couple of days with a CCC crew to put that in. Next, we're going to use the green armor system where we use the Flex Terra and sprayed it right into the Inca mat. And we want to be able to spray the Flex Terra hydromulch, the BFM, right through the interstitial spaces, and so it touches the soil. Now, this is the Nacella pulchra we actually put down in the compost before we laid the blanket, and we put a little bit of Nacella seed and native seeds into the hydromulch also. Next. So here we are done on March of 2015. Next. There's my dog checking it out on March 1st. And the next slide here shows March 23rd. And you can see the BFM is down, bear's going, yeah, this looks pretty good to me. Next. Within a year, those tall grasses are Nacella pulchra growing. It's unheard of to get native, people say native grasses aren't going to work in 1 year. They take 2 years to get established. Not when you use mycorrhizae, not when you add compost, and not when you don't use commercial fertilizer. You're out competing. The natives then have a chance to outcompete the annual grasses, which rely on all of our standard agronomic practices. Next. Purple needlegrass is already seeding in 2016. Next. Okay, so that's a little case study how we use the compost to reestablish native grasses and do erosion control. The compost blanket is remember, 99% effective, an inch or two thick. Use it on one-to-one slopes with proper roughening. It doesn't have to be 2-to-1, 1-to-1 it's being used. The Texas DOT, as we heard yesterday, been doing it for 20, 25 years and documenting it. The picture on the right is a job we did in Auckland, New Zealand. They have several blower trucks and the use of compost in Auckland. It's also very popular in Australia. Next. We did a little research with Jack Broadbent and Vic Claassen, UC Davis research on nasty cut slope, or nasty road cuts, basically on Highway 299 West, decomposed granite, hydro group of 1. It's a very porous soil. Okay, next. So to do this study, we wanted to see how much compost to incorporate to increase infiltration rates. There's Vic Claassen on the left. We built first we built a gabion toe wall. That gabion baskets were lined with, mulch, with coir netting, and then filled with decomposed granite. Just a natural way. This still exists there. Maybe think about this up in Tahoe when we have to build these expensive retaining walls for erosion control. We could just use gabion baskets filled with compost and a compost amended granite. So we built 16 plots. Next. And we mixed various rates of compost we mixed 2%, 4%, 6%, and 24% of compost by weight of soil. Next. And here's some of the trials. You can see 0% on the left, you can tell just by the growth. Now the bottom part of the plot didn't have any plants in it because they wanted to test infiltration rates without grasses. But look at right next to it at 12%, you can see the increased growth. Look at the third one over, 24%. Not only do the grasses look really well, but they infiltrated a 10-year return interval storm. The final report on the bullet there shows that we were able to infiltrate with 24% compost. We were able to infiltrate 1.8 inches per hour. We took as we did the highway, we took a reference site, a very historically erosive site on this highway. And after 25 years, it looks pretty normal. We go, what made this normal and erosion proof? So we measured the infiltration rates. It was the reference site, we call it. It was 50.6 millimeters per hour. And at 24% compost, we were able to match the reference site. Next. So again, and then we were able to grow better vegetation. So, we're going back to Jim Phillips's talk also. What would our recipe be? Well, we're learning that we can greatly increase infiltration rates. We had roots that grew 4 feet in 1 year. We can hold the soil apart, decrease the bulk density with 24% by volume. So remember that. Maybe that's the recipe you want to use if you want to maximize your infiltration rates on that DPPIA area, for instance. Next. And then we continue to go up and continue to repair the slope. Let's go on up. Jack, next one. Kind of interest. We use the compost mix to build this fill cut. It's 1-to-1. It didn't need to be compacted to 99%. In fact, just dozer packing it, we got 90% compaction. We were able to reinforce it with coir netting. We invented the soil flap technique, and we used brush layering to reinforce each lift. Next. So here's the biotechnical. We were tested during extreme winter Next. It's the first time we'd been able to build a erosion-proof project up there in the decomposed granites. Later, next slide, later they had to go in and realign the highway, and a lot of that material, those studies were removed. Over there on the right, you'll see the gabion baskets had some willow incorporated in it. And again, that could be that long growing vegetated retaining wall we all might want. There's more information on this popular research that articles written. And if you go to www.dirttime.tv, I have all sorts of articles and case studies posted on that website. Next. An example of using the compost berm and blanket in Lucas Creek, New Zealand, an urban stream where we did almost 2 miles of stream. Not only was compost blanket used, as you can see, and the compost berm, we also used compost socks. They call it down there a living wall. And you can actually build up your embankment using the reinforced compost socks. Next. So they were able to withstand high floods. This was done in 2010. I've been back several times, 2016. You can't even see the structures. We used naturally occurring materials. We used the NCHRP report 544, alternatives to riprap study that we did in 2005, and all the DOTs that accepted. Notice we're using large woody debris. Root wads were actually used an excavator to pierce the root wads right into the embankment. And very little rock. There's not a lot of rock in Lucas Creek. Next. So the next, we were filming a big cover-up episode of Dirt Time. Next. The big cover-up episode at Shasta College, erosional training facility, was going to be to, as you can see on the upper left-hand, we were going to test straw mulch versus erosion control blankets versus hydro mulch versus compost blanket. And what's interesting, the slide just below it, we put the compost blanket down 2 inches thick. Can you notice the wheel rut there? I want you to keep an eye on the wheel rut at the upper edge of the slope. This was to make a movie. I didn't know that we were going to get an 8-inch storm in 4 hours within a couple of days of this installation. You can see at the toe of the blanket is a compost berm that we installed. I made the berm like little smiley faces to reduce the drainage area, the receiving waters, if you will, up to the berm. Next. So Reading received an 8-inch storm in 4 hours. I measured 4 inches in 1 hour. A couple of people, one person died in Reading during the storm. The streams and flooding occurred rampantly. The next day, we ran down to Shasta College to see what happened. You can see the compost blanket did not move. Neither did the compost berm. You can see it caught sediment, the berm did. The sediment came from that tire rut. One of my students drove up on the slope, formed a tire rut. The 4 inches an hour concentrated on and formed those little ruts. The compost didn't move. Please embed this in your memory when people tell you that compost blankets have to go down at 2-to-1 maximum. Just that's not true. Now, I want to mention this was compost Reading green waste. It was medium gradations, medium to fine, and I didn't put a tackifier in it. Next. I did put, because we were filming it, I did put rye seed in. I wanted to demonstrate how the hopper will mix the seed in the compost blowing machine. But I've never used rye in 25 years. This is the first time I've used rye. I always use native grasses. But you can see after 24 days, the rye really shows how well the compost did. Next. So we're taking that information with us. I want you to think of the compost blanket as a sponge, and the sponge sits there and it has a really high infiltration rate. The compost, especially the compost that's pneumatically applied with the compost blowing machine, it's so loose that it infiltrates the water, it absorbs the water, and it gradually releases the water into the soil. The proponents say it infiltrates and holds 10 times its weight in water, and I believe it. Next. This is an old hilltop burn dump. I'm gonna move kind of fast through this one. 10-acre remediation for 60,000 cubic yards of fly ash. As the fly ash was covered, it left 10 acres susceptible to erosion. The agency responsible did not put any hydromulch down. We received 500 tons of sediment in the first 2 storm events, and that was back in 2001. Next. We were left with a burn dump with a city trail that was covered with noxious weeds predominated by star thistle. Next. Got a grant, asked what can we do to reestablish the natives? There was no topsoil per se left. There were drainage ditches were there. I couldn't put any equipment on the slope. The only thing I could think of was to add 700 tons of compost green waste, blow it on top of the slopes, add mycorrhizae, of course, add very slow release fertilizer, biosol at only a tincture of it, 500 pounds per acre. The seed mix predominantly south-facing Nacella pulchra, and it was all applied with the express blower. Next. With the blower machine, you can blow up 200 feet. When you have the machine, you can also lay the berm down. And remember, it's an alternative silt fence. That's the biggest thing I see the berm as. We could replace even a half of the silt fences used by the DOTs with compost berms. We would use a lot of compost. So replace the silt fence with the compost berm or the compost socks. Next. The machine also allows you, next, besides laying the berm, to lay the compost sock in place. You just slide it on, slide the sock on, and you can go and lay a sock very, very fast. Next.
You got 2 minutes.
Thank you. So May 2004, we're starting to get sprouting. Over there on the right, by 2007 and 2005, those are all native grasses that are growing. So within 3 years, the predominant grass up there is Nacella pulchra. That's pretty, I've never seen anything like that, where you could convert star thistle and annual grasses to a native grasses again in that short a time without using herbicides or anything. Okay, so I want to thank you for this coming to the workshop. Bear thanks you. The Nacella pulchra of the world, the south-facing predominant grass. Remember, it lives for 200 years. It's my hero. It sends down roots 6 feet. That and Elamus glaucus and Romus carinatus. Remember, these are mycorrhizal dependent grasses. They need mycorrhizae in the soil. If your soil has been denuded, subsoil, after a fire, the mycorrhizae is dead. So we really need to start thinking about when to add mycorrhizae back in it. I hope today I gave you enough examples where you can see the proof is really in the pudding. So I will leave you with that and open up for some questions.
Okay, John, that was great. Really appreciate that. Since you were just talking about mycorrhizae, why don't we take the first couple questions on that? I don't think we have a mycorrhizal company sponsor for this, so we should keep the answers short. That was a joke, John, just so you know.
Oh, okay.
Okay. How are you typically, what are the methods you're using for adding mycorrhiza into the compost, or if you're going to use compost in the application?
I've been using a compost or a mycorrhizae. It's called AM120, arbuscular mycorrhizae. Arbuscular means it grows into the buskule of the root of the plant. That's the mycorrhizae we want. It's got 6 different genotypes in it. It's been added and stuck to kitty litter, so when you spread it, you can spread it pretty fast. This is the one I use, and it comes in a 20-pound bag. I use about 20 pounds per acre. I like to throw it out during the final grading, like when we're track walking or surface roughening. Anyway, remember the mycorrhizae is spread through the soil. It's spread by alighting on the nose of a worm, or it gets on the tip of a root and it spreads through the soil. So I like to think of adding my mycorrhizae propagule or spore into the soil a little bit where the roots will come in contact with it. So I like the AM 120, 20 pounds per acre. I've seen old Caltrans specs had 60 pounds per acre. I think that's a little much. And there's many different sources of it. Okay, next.
No, yeah, now John, you can you add that into the seed canister on the blower trucks also to apply that, or is it not effective?
Very good question. Yeah, you add the seed and the mycorrhizae into the canister. What's really interesting is the express blower and the Peterson trucks are calibrated. The operator can calibrate the seed mix out of the hopper and fertilizer also. And when I asked for 40 pounds per acre of seed mix one time on the Hilltop Burn Dump, the size of the seeds I had, that came out to about 70 to 100 seeds per square foot. So as he's blowing it, I went out there and would lay out like a little hula hoop and measure a square foot and count the seeds. And it came in 70 to 100 seeds. They had it dialed in perfectly. The same with the mycorrhizae. As the compost goes pneumatically applied, there's a helical flow down the hose, and it mixes all the components together. When they come out, they're really well mixed and uniformly mixed.
Okay, so that's great. Let me ask you a couple things about seed. Couple questions came up. Have you noticed improvements in germination rates for grasses when mixed with the compost? And are there specific species that respond better than others?
Well, again, the only the grasses, I did a study at Shasta College. We did hydromulches, no hydromulches, 2,000 pounds per acre, 4,000 pounds per acre, and also a plot with 2 inches thick of compost. I used the native grasses that I'm the most familiar with, Nacella, Elamus. I put it in the seed mix at 30 pounds per acre, and I got 10 times the grass establishment from the seed being under the 2 inches of compost. Yeah. I also applied the seed, scarified the compost. Someone said, well, maybe the compost will smother the seed. So I went back and scarified half of the compost plot and applied the seed kind of in the surface. And there was no difference in establishment. The seeds grew great through the 2 inches of compost, and they grew great when they were applied on the surface and scarified in.
Yeah, I think that's kind of an interesting comment too, John, because those of us who've gone to ag school, we know that the plight of burying seeds too deeply, but that rule really doesn't seem to affect when you're blowing it in the compost. I'm assuming it's because there's more energy and there's a lower bulk density for the seed to go through.
I think you're right. Yeah, I think you're right, Ron. A lot of the rules for soils that we learn in soils labs and stuff are thrown out when you start thinking of compost.
Yeah, absolutely. Okay, so we already talked about seed mixing. One of the questions that came up is, and I wanted to go back to this one, the Clausen work you did. I think I read that study, and where you used 24% inclusion rate. Was that a coarse compost that was used in soil incorporation there?
No, it was red and green waste. At the time, they, in order to meet at the time 1%, because it is green waste, it had plastic pieces in it. And in order to get enough 1% or less plastic, they had to screen it. They kept screening it to get rid of the plastic. So it was primarily a 3/8 inch green waste, and it came from Redding Green Waste Facility.
Okay. Question came up. You used the term brittle environments. Could you explain what that is?
Yeah, I'm using holistic resource management. Alan Savory describes it. He started noticing the way the savanna in Africa worked, and the use of animals impacts and the use of fire, and then brought that technology to ranchers in brittle environments here in California and Washington. So it's an area that gets very low rainfall. It's at a critical equilibrium. It's in a fragile, and if you do anything to damage it, it's very difficult to reestablish. In fact, we have a complete turnover of vegetative type, as we've seen with the ranch land being overgrazed.
Okay, I want to ask you one more quick question. I'm going to paraphrase a question. I think I have it right, but the question is, do you have any concerns in using seeds? And I'm assuming they mean grasses, where native species are being grown.
Well, I was going to mention that in my curriculum vitae. I have not, in 15, 20 years, I have not planted anything but native grasses myself. I believe, and I was doing construction BMPs for years and developing a seed mix for the city of Reading. And I believe that we have bare soil on a construction site. That gives us, every time we have bare soil, we have an opportunity to reestablish natives. And I'm a believer of that. And so I have not planted non-natives, except in my lawn.
That's fantastic. And if you had any problem, there's a, I'm going to ask you the real quick question though, because we're out of time, but have you had any experience, using different flavors of compost, different feedstocks of compost in establishing natives, or has it primarily been with the yard trimmings compost?
Well, yard trimmings, but the most beautiful compost I used came out of Canada. A lot of that was the wood source. So you don't have to worry about having microplastics or anything in it. And you can use, get coarser grades, and you don't have to worry about any contaminants. And that brings us to Northern California. We have all the fire problems in Northern California. And the map that Mr. Cotton showed us yesterday of the compost facilities, most of them are in Central California or Southern California. So we're going to start having to have some compost facilities up in the North State. So as we start removing biomass from the woods, this quality compost, we're going to be able to process it in the North State. That's just a personal view.
No, it's got to happen. So thank you for that wonderful presentation. Thanks for answering all the questions succinctly, John. And Brian, I'll pass it on to you.
Thank you, Ron. Our next speaker, Scott Dowland, is currently a senior landscape architect for the California Department of Transportation, a certified professional in erosion and sediment control, and has 20 years of experience practicing transportation landscape architecture. Scott will discuss how Caltrans uses compost to protect water quality, establish vegetation, and build healthy soils. Scott?
Okay, Brian, thank you for that introduction, and thank you everybody for participating today. I'm really excited to share with you how Caltrans uses compost to protect water quality, establish vegetation, and build healthy soils. In this presentation, you're going to see similar conditions and applications as John and some of the other presenters today. But what I think that does is that further validates that although we are using these in different areas and locations around the state, nation, and the world, that these practices really do work. And, these aren't controlled environments that we're working in. These are real world applications. So I hope to show you some more examples of that. Next. This project is on Highway 101 in Monterey County, California. And this is a photo of one of the 3 interchanges that were constructed as part of that project. As you can see, we were niching in, it's a rural condition, we were niching in the interchange into the native landscape. And so we were dealing with a lot of topography changes, steep slopes, long slope lengths. And with this project, we ended up using over 45,000 cubic yards of compost. We applied it in varying types and applications, covering over 108 acres. Next. So the main challenge in controlling sediment and erosion had to really do with the soil type. So scientifically speaking, the soil or the site consisted mainly of aroma sand, and that's a cross-bedded sand with clay layers. This soil is highly erosive, it lacks organic material, and has a low water holding capacity. As a result, it made it really difficult to control erosion and establish vegetation. And then from just the practical, realistic situation, we've been dealing with erosion on these old road cuts since the 1950s on this segment of highway in the corridor. And, you know, we've been doing the same treatments and we just find they're just not working. So coincidentally, in 2005, when I first started working on this project, a group of individuals, which actually consisted of a lot of the people that that are behind the scenes and presenting this workshop today, actually came to District 5 in San Luis Obispo to give a compost workshop. And I heard what they were saying. They showed examples, and I believed in what they were saying. And I also believed in Mother Nature. And I think going back to what Britt Fawcett had said yesterday is this idea of biomimicry. And really compost is bringing back that organic matter, that O horizon, that we need to kind of kickstart the biological cycle. So that really led me to a career of using compost, advocating for compost, and documenting the use of compost on transportation projects. So what I'm going to present to you today is a summary of all the things that I've learned over the last 15 years using compost on large-scale projects. Next. So these next few slides are how we use compost blanket for slope stabilization and vegetation establishment. So the concept here is that we're using compost blanket topically applied, 2 inches thick. It's a fine compost on steep slopes with long slope lengths. In this photo here, we have over 100-foot individual slope lengths that are broken up by benches. And then because we wanted a real aggressive type of treatment, we use core netting and hydroseeding over the top. And so essentially what compost is doing is it's serving as an initial mechanical erosion control measure to prevent raindrop erosion. And this is essentially due to its high water holding capacity and its protective cover. And then it really allows the slow movement of water to then percolate into the ground. And then once the slopes are stabilized, the organic matter and the nutrients then help to build the healthy soils that support the establishment of vegetation. And then that vegetation really becomes the long-term erosion control. Next. So here's that same site 6 months later, relying on natural rainfall. And you'll see here, it's a real thick, dense stand of native vegetation, which is really different and unique from our previous experiences within the corridor, where we got low vegetation establishment. And when we did get vegetation establishment, it consisted of a lot of invasive species and annuals. So this was quite successful. Next. And in this application, we again used the 2-inch thick compost blanket, but then we covered it with a blown straw and tackifier. And so that straw is really providing that extra level of mechanical stability and protection. But then that compost, again, brings in that water holding and nutrients that help establish vegetation. And you also see with the use of compost, we found that we were able to limit the amount of linear sediment barriers that we're using. So that not only saves costs, but I think it also helps the kind of the landscape transition quicker into its natural state. Again, that's the same treatment with the straw 6 months later. Again, that real thick establishment of native vegetation. And really the reason why compost contributes to that establishment of native vegetation, it's really the nutrients associated with the organic matter, and then having that available moisture associated with the high water holding capacity. So the combination of those two things are just really ripe for establishing vegetation. Next. Here, again, we use the blown straw technique, but then we further punched it in and really incorporated that straw into the compost, into the soil. So it helps kind of bind the soil and straw for added soil protection. But honestly, we saw really no added benefit with that additional measure than we did with just compost with blown straw over the top. So ultimately, at the end, we ended up just eliminating this extra step and saving some money in the installation costs. Next. So now I'm going to talk about compost berms. So we're using compost berms as linear sediment barriers. On this project, we primarily used them as mid-slope sediment barriers in lieu of fiber rolls. They were pneumatically applied with the blower truck. Really, the shape of them is not really as critical as this bulk and mass associated with them. And so essentially, we were installing them about 2 feet wide, about 1 foot high. We used a medium grade compost. And what that allows is it allows enough permeability for water to move through it, but it also has enough fines to help establish vegetation. And so then once you go ahead and seed these berms, they start to vegetate, and really the vegetation and the root systems knit these elements together and provide added protection. And then once you've got the additional area hydroseeded and that vegetation starts to establish, then these things just kind of really just blend in with the roadside and they just disappear. Next. So here's an example of a compost berm functioning. And you can see where we had a concentrated flow and sediment starting to move over the slope. These berms were able to capture that sediment, hold the sediment in place, but then allow the water to continue to move through the soil. And what that does is it it minimizes the hydrologic pressure that's building up behind these linear sediment barriers. So unlike a fiber roll, where you typically find fiber rolls fail because of that hydrologic pressure that builds up and either causing undermining or overtopping, the permeability of these compost berms just allows that water to keep moving, but it does capture that sediment. Next. So we're also using the compost socks as check dams. And you can see in these photos on the bottom right how effective it was as a check dam. For the compost socks, we're using the coarse compost material. Again, that's really promoting that infiltration, letting that water move through, preventing the undermining, capturing the sediment below. And then the other benefit with compost socks as check dams is that because they have a lot of mass and weight to them, that when you lay them on the ground, although they're coming around sock, they flatten out on the bottom. So you get a lot of good soil to linear sediment barrier contact, really preventing that undermining of material so that all the sediment then stays captured behind the fiber roll. Or excuse me, behind the compost sock. Next slide. So we had the unique situation of seeing kind of the difference between kind of traditional erosion control applications and compost applications. So this is what I call our erosion control performance comparisons. So on the project, here's a cut slope that had temporary erosion control using bonded fiber matrix and fiber rolls. We had a high intensity rain event. This is just after one event. And due to the type of soil we were dealing with, the rain just really kind of melts the soil, and the bonded fiber matrix and the fiber rolls just really weren't up to the job. And then I talked about that hydrologic pressure that builds up behind fiber rolls. Well, on the bottom right photo, you can see how once that undermining starts to occur, then you get these major rills and gullies, and to correct it, you have to go back and rework the slope. So it's really expensive to do that. Next slide. So this is one of my favorite photos, and it's not photoshopped. It was a condition where we had actually covered the top 2/3 of the slope with permanent erosion control using compost, and then the bottom third was the temporary erosion control using bonded fiber matrix and fiber rolls. And so you can see how the two really perform. Now, I'd say it's really not an apples to apples comparison, because at the top slope, you've got up there, in addition to compost, we have netting. We also had vegetation establishing. So really, I think what can be learned from this photo is it's really important to get permanent erosion control on these slopes as soon as you can, because the permanent erosion control is really going to be your best bet at protecting these slopes from erosion and sediment loss. Next slide. Yeah, but this photo, I think, is an apples to apples comparison. And so on the left-hand side, it's just BFM. And on the right-hand side, it's compost with BFM over the top. And you can see how the two performed under the same rain event, same slope angle, and slope length. And really, there's just no comparison between just plain BFM and BFM with compost. And the difference is that compost is there protecting that soil surface. It's also maximizing the water holding capacity, which is preventing water runoff. Next slide. So compost blanket does have limitations, and that is concentrated flows. It does not like concentrated flows. So you can see in this photo, the intention was to go ahead and cover this slope with compost blanket, 2-inch compost blanket. But because the natural undulations in the road surface, water naturally kind of concentrates in particular areas. And then as it moves down the slope, it starts to create rilling and gulling. But that said, even with the rilling and gulling, I would say in this condition, I would not call this a failure, because what happened, even though we did get some movement of compost, what we did get is very quick establishment of native vegetation early on, and those rills and gullies were very minor. But I think it is worth noting that compost does not hold up against concentrated flows. Next slide, please. So this kind of goes back to what John was talking about in his last presentation. So there's a conversation that compost blanket does not like steep slopes or to be applied in windy locations. And so this project is on Highway 1, just near the Big Sur. It's on the Pacific Ocean. And this was where a landslide occurred. And you can see where the white K-rail is delineating the roadway. Essentially, that whole roadway went into the ocean. We ended up building the slope back up at a 1-to-1 and reconstructing the road. And so what we were left with was 1-to-1 with 300 to 500, I think possibly even longer slope lengths than that. And so the question was, how are we going to go ahead and control erosion and sediment on this hillside? And we don't want it going directly into the Pacific. Based on our experience with compost, we decided to go ahead and go with it. And so The soil was had a lot of texture and undulations to it, just because of the type of landslide material it was. So it provided really good nooks and crannies to accept the compost. So we went ahead, we applied compost over the top from the top to the bottom and bottom to the top, getting good coverage with 2 inches thick compost. Then we went ahead and hydroseeded it with hydraulic mulch and tackifier and seed. And that was done, those were same day applications. And so we had some luck as far as timing. I wouldn't go ahead and recommend applying compost blanket during windy events. However, if you do have still events, which we had, we were applying it in the morning, buttoning it up by the afternoon. In the afternoon, we were having, pretty strong winds, but all that really protected it in place. We didn't have compost moving. And then after that, we continued to have rain events. And next slide. And so here's what we were left with. And I think the consensus was, before we applied compost, is like, how the heck are you going to vegetate this material? It's sea horizon material. I mean, it has no organic matter. It's fresh from the earth. How are you going to establish vegetation? Well, just the minimal amount of 2 inches of compost with hydroseed gave us this thick stand of native vegetation. And so, another testament to this stuff really does work, and it does work on steep and windy applications. Next slide. So here's another project where we're doing some site restoration to establish coastal prairie grassland. And so this is a roadside pullout that was left over from landslide material and serpentine soils, which you can see doesn't really vegetate very well. And so it turned out to be these parking lots. So our goal was to go ahead and reestablish these areas into coastal grasslands. And so to do that, next slide, what we did is we incorporated 4 inches compost, 8 to 12 inches deep, and then topically applied that with another 2 inches of compost, and then came through and hydroseeded it and mulched it with native grass straw. Next slide. 2 years later, we ended up with a dense stand of Nacella pulchra and Bromus carinatus, which is really incredible given the material that we were starting with. I mean, to see this amount of vegetation and density was very impressive. Next slide. So on the same project, we also had kind of these roadside trails that were being used off the highway. And so we wanted to, and so what was happening in those areas, they were degraded sites. There wasn't vegetation growing, they were compacted. Well, what are degraded sites with compacted material like? Invasives. Invasives love kind of populating those areas. So we came in, we cut the invasives down, and then we incorporated compost, just 2 inches of compost this time, 4 inches deep. And you can see in the bottom left photo what we were left with. And what you can see is there's this green stripe down the center, and that's the area that we amended with compost and hydroseeded with natives. And what's unique about this is that this photo was taken in August, and you can tell by all the brown grasses on the native landscape around. Everything's dried out and brown. But the area where we applied compost is still green. And that's, again, a testament to that compost has that water holding capacity. And even though it's as small as just 2 inches thick of compost, and then by the time you incorporate it, 4 inches deep, it's really just kind of a dusting, but there's enough organic matter there and biotic activity and nutrients to sustain green vegetation in August. Next slide. And then we're using compost for habitat creation. This is, again, on the Big Sur coastline off Highway 1. And here we used it to establish coastal prairie wetland. So to build the coastal prairie wetlands, we're excavating the natural topography down. We're removing the O and the A horizon. We're getting down to that B and C horizon where we don't really have any organics. And so we need to, in order to reestablish vegetation, we need to reintroduce those organics to kind of kickstart the biological process. And so in the combination of compost and using clay for water holding capacity, we kind of use those together for each of their own purposes, clay for the water holding capacity and then compost for the nutrients. We were able to successfully build these natural wetlands that sustained water and native plant growth. And so I think without the compost, it just would have been so much harder to get that level of vegetative growth to begin. Next slide. Here is an example of where we're using invasive or we're using compost incorporate for invasive weed suppression. And so coincidentally, these two photographs are right next to each other. And in fact, the top photograph, if you look at the back right corner, that's really the site that I have blown up as the herbicide. So they're right next to each other. And it was kind of it was kind of an incidental experiment. We didn't expect this to happen, but we had a site that we were incorporating compost to establish vegetation, and then next to it, we weren't intending on doing any work, but we wanted to control the invasives. So we had specified that the invasives be controlled by herbicide. But what we found is that with the compost incorporation, we got this real dense stand of native vegetation, which outcompeted the invasives and suffocated the invasives out. But where we had the herbicide, it became this routine application. Every 6 months, you got to reapply herbicide. And as a result, the herbicide risks polluting the environment, and you don't get a very biodiverse environment of plant species. And so you essentially get this just burned out landscape. Whereas next to it, we've achieved the goal with eliminating invasives, but we have this rich biodiversity of native plants. Next slide. Here's another example of that, and you can see, so the top left is where we use compost incorporation. That was 2 inches, 4 inches, 2 inches of compost, 4 inches deep. And then on the right-hand side was the herbicide where we had stopped that compost application. And again, just another example of how well compost is at stamping out invasives and really promoting native vegetation establishment, which outcompetes the invasives. And actually, one other thought is, is this idea that the invasives really like the degraded, non-vegetative sites where the compost allows native plants to take root early and outcompete. So also we're using compost for biofiltration. And so another example of compost incorporation. This project is located on Highway 46 east of Paso Robles. It's a constructed bioswale. And then at the side slopes and at the bottom of the bioswale, we incorporated 4 inches of compost, 8 inches deep. And so really what that provides is we're getting the infiltration and the percolation of water down into the ground water table. And then the vegetation is also serving as filtration and filtering out any of the pollutants and sediments that are coming off the roadway. So kind of a dual approach with that. Next slide. On that same project, we had some creek crossings. on those creek crossings, we needed to stabilize the banks and also the bottom of the channel to prevent erosion. And so with this, what we did is, again, we incorporated compost. We wanted to make sure that the compost was incorporated into the native soil so that we didn't get movement of compost material downstream. And then after a few rain events, luckily before any major heavy rainfalls, we're able to establish this dense stand of vegetation, which ultimately provides that bank and channel protection that we were looking for.
3 minutes. 3 minutes, Scott.
Thank you very much. Here's an idea I think John talked about, and I want to reintroduce this idea of the ability for compost to sequester carbon. There's a lot of research out there about that ability, and I know Caltrans is looking into it. And this is a calculator that it's called the Comet Planner, and it was developed by Colorado State University, the USDA, California Air Resources Board, the California Department of Food and Agriculture. And really, it's a way to calculate and estimate greenhouse reduction for agricultural use. But if you apply that to the roadside, there's one of the models is grazing. And so when you apply that to the roadside, I calculated how much compost District 5 used in a year. And it turns out with the amount of compost we use, we were able to sequester 4,000 tons of carbon per year, which is equivalent to planting over 16,000 trees every year, or the reduction of 10 million vehicle miles traveled. So this is a real big opportunity for Caltrans to use compost to offset our greenhouse gas emissions. Next. I just want to quickly talk about the particle size specification. So for fine compost, I'm primarily using that for soil amendment and incorporation. The medium compost is primarily used for soil protection and native plant establishment. And then coarse compost is for the filter socks and sometimes filter berms, but honestly, I think the berms work better in the medium compost. Next. And then my last slide here is talking about physical contaminants. So our specification, as Mike mentioned yesterday, should not contain more than 0.5% of physical contaminants by volume or weight, and not less than 0.1% for film plastic. And then for medium and coarse compost, it's 1% for physical contaminants, but still held at the 0.1% for film plastic. So although this used to be a kind of a major issue for us, really with the collaboration of the specifiers, I know Mike Farrar did a lot of work in working with the manufacturers and advocating for the reduced amount of trash in our compost. We've really got to a point where the compost just within the last 3 years is much cleaner than I've ever seen it. I'm really excited about that opportunity because it takes off a whole issue of concern. But I also want to point out even with this low percentage, you're going to want to make sure that you evaluate your sites, and if you're an environmentally sensitive area, kind of understand what your issues are, what the concerns are, and make sure you evaluate your compost before it gets out into the field. So with that, are there any questions?
Okay, Scott, thanks for that. That was really, really good stuff. First question, right off the bat. The distance seems exceedingly far on that Big Sur project. How did you get the compost over the whole slope?
Yes, it was blown from the top down and the bottom up, and I believe that they had guys on ropes that were rappelling down to hit the midsection.
Wow, that's amazing.
Yeah.
There was a couple times you referenced a 2-inch application rate of compost incorporated into a 4-inch depth. Is that a standard for you? And why aren't we incorporating the compost deeper?
Yeah, I have used that, developed that as kind of a rule of thumb, and really it's about kind of a 2-to-1 ratio that I use. And I think if you want to incorporate deeper, just use more compost, because I think at some point you're going to lose that good ratio of compost to native soil. So with 2 inches of compost, I'll incorporate 4 inches deep. If I want to get an 8-inch deep incorporation, I'll go 4 inches of compost thick. If I want, 12, I'll go 6 inches. And so I think that gives it a good ratio between native soil and organic matter without diluting it.
Right. Okay. Is there a means in which you're determining when you should use a compost berm versus a compost sock?
Yeah, that's a great question. Absolutely. So I've been using compost berms as mid-slope interrupters, and then compost socks at the top of slope as a first line of defense. And compost, because it's much more durable against concentrated flows and that initial impact. And then I've been also using compost socks at the toe of slope as my last line of defense. So essentially a first line of defense, a last line of defense, and that seems to be a good combination between the two.
Okay. And the question came up, does the RWQCB, I guess the Water Control Board, does it accept compost berms for sediment control in lieu of fiber rolls?
My understanding is yes, because we use it routinely here in District 5 in lieu of fiber rolls, and I've never had it. Our stormwater has supported that, and I know that they're working with our local water board on that.
Okay. Is there any repairing that has to get done during the project?
Yeah, I mean, if there was a blowout of a compost berm, absolutely. I think you would repair your compost BMPs just like you would repair any other water pollution control BMP.
Yeah, that's great. That's a great answer too, because sometimes we have such good success with some of these uses. People think it's a panacea, and it's still a system, and it's a system living in the environment that's got to deal with it.
Yeah, and I think another point to that is this having expectations. It's not that panacea, and also, I mean, we're getting fantastic results, but if your expectation is 0 failures and no sediment loss or erosion, I think that's kind of an unrealistic expectation. Yeah. So yeah, you're gonna see some failures here and there, but the fact that compost is able to meet so many different objectives is really impressive. We're protecting the water quality, we're preventing erosion, we're building healthy soils, we're establishing vegetation. So those are a lot of different objectives that we're able to achieve with the application of one material.
Yep, I totally agree. Scott, great presentation. Thank you for answering the questions, and I'll pass it on to Brian for the next speaker. Thanks again.
Thank you, Ron. I wanted to mention that CalRecycle is working with California Air Resources Board on developing a methodology for estimating greenhouse gas emissions from the use of compost in landscaping. And we're in the process of setting up some meetings with Caltrans, CalRecycle, and ARB to work on that. Our next speaker, Jeff Peterzak, is a senior landscape architect for Caltrans at headquarters in Sacramento and has 27 years of experience practicing landscape architecture. He graduated from the University of California, Davis, the Bachelor of Science degree in landscape architecture, is a licensed landscape architect, and a certified professional in erosion and sediment control. For over 15 years, he has designed roadside design solutions for Caltrans spanning the North Coast, Sacramento Valley, Sierra Foothills, and the Sierra Nevada. Jeff has found that design challenges within these environments includes climate, parent soils, and construction soils. He embraces the use of compost in design solutions in order to build healthy soils, protect water quality, and reestablish habitat. Jeff will discuss the lessons learned on applications and use of compost of various Caltrans projects throughout the state. Jeff?
Thank you very much, Brian. All right. Well, and thank you all of the attendees that are participating today. We've had a wonderful turnout, and this has just been a great event. And I'm very encouraged that we're discussing the use of compost and how we can use more of it. So as Brian mentioned, yeah, my name with Caltrans for about 20 years now, but working as a landscape architect, gosh, for 27, almost 30 years, it's crazy. And you know, it's an interesting thing. I look back over my career, and we always amended our soils when we would plant materials. You know, back in those days, and over the years, there's been changing opinions about that. I was fortunate enough to come on with the department at a time we heard a little bit about over the last decade or over a little bit more. The department's gone through a lot of changes with our erosion control approaches and the embracing of the use of compost. We've come up with specifications and trainings in the past to support that. I came in at a time, as Scott, whom we just heard from, did, that I was able to apply this to projects. So let's talk about that a little bit. Next slide, please. So a lot of call sustainable erosion control. And so what is this, and why is this important? You can go to the next slide, please. We have some different goals that we have when we're doing erosion control, which we do on pretty much along the roadside, at least in Northern California. And we have vegetation goals, things we want to achieve there about developing healthy plant communities and having diversity in our species, having the depth of rooting, as John McCall, so that we can have sustainable vegetation growth over time. Next slide, please. We have water quality goals, as we heard a bit from Jim Phillip about reducing our erosion. And we want to reduce the runoff coming off of our construction sites. We want to keep our water on site and treat it in place. And we want to have the same or better improved post-construction water quality when we're done and we've completed our project. Next slide, please. And then we have goals for the soil itself, right? We want good infiltration into that soil. We want adequate organic matter that can break down over time and provide nutrients to the soil, provide a good environment for our plant material to grow. We want sufficient water holding capacity so that environment doesn't fail. Say it's in a slope condition, it should be able to accommodate the design storm event in some manner, whether that is it's infiltration or we've diverted that water off the slope in some other way. And we want to build a favorable soil environment with the proper biology and microbes required for sustainable vegetation growth. So next slide. So what we're really talking about is sustainable erosion control triangle. And when we apply this, we're able to establish a long-term natural environment that requires little or no maintenance in the long run. And this is achieved through biomimicry, which we heard mentioned yesterday. And that approach is by trying to replicate the background native environment. And so what does it really take to make all three of these elements are required to work together? We have to really look at this like it's a three-legged stool. If we remove any one of the legs of the stool, then the stool is going to topple over. So vegetation is going to require a native or acclimated seed bank. And usually this seed bank is still present in the surrounding environment around one of our roadway construction projects. And so typically where we're going to talk about in Northern California and up into the mountains, there is a native, so it will tend to reestablish itself over time. But we may jumpstart it and incorporate a native reseeding mix into our erosion control solution. Water. So we have, in a required adequate amount of annual water that's required in a given area for successful vegetation establishment. And we're not really affecting that with our construction operations, the amount of water that's coming into the construction site. But soil, we require a healthy soil for successful vegetation. So you can go to the next slide. So with Caltrans road projects, which of these three is most affected by construction operations? We typically don't affect the local seed bank, rainfall, but we do a pretty good job of messing up the soil right away. First order operations is coming in and clearing the site out, and can start turning into compacting of the soil surface and mixing of the soil profiles, turn desirable topsoil and turning it into a subsoil where it's not going to be able to be accessed by the vegetation. These are exactly the types of things we don't want for successful soil. And as we mentioned, the key to successful soil is its physical and biological environment that helps to optimize infiltration, sustain native plants, and create favorable conditions for microbial communities. So next slide, please. So I just mentioned the soil profile, and really what's typically disturbed with construction operations is the upper organic, the O horizon, and the topsoil A horizons. Construction soils typically become a mix of the B's and the weathered bedrock C's, with some of the A's and O's are in the mix. But they're turned over into these subsoils. Or maybe even soil is just imported into a project site entirely from some other location. We don't even know what that origin of that soil type is. So where does that leave you as a designer? How do we replicate a proper soil profile in a disturbed roadside situation? Well, we have a few options. We can import topsoil, like I just mentioned, bring in a better topsoil. It's expensive to do this, but it's typically pretty effective to do that. We can stockpile and replace the O and A horizons to a specific depth. Go in there before construction disturbs it and grab that away and stockpile it, and then bring it back as part of our erosion control solution and put it back on a little later. This is a little more cost-effective of approach than importing topsoil, but it is difficult to coordinate through the construction office, and we need to actually have the amount of space available on the construction site to allow this to happen, moving piles around. So the other benefit that it has, though, in grabbing that is it gets all that the soil biota. We heard John mention mycorrhizae. If that existed in that soil profile prior to construction disturbance, well, we just captured it and we stockpiled it on site. We'll be replacing it back after we're finished. So there's a benefit there. But what works really well and is relatively inexpensive is simply using compost for soil building. It provides a tool in the designer's toolbox. Go to the next slide, please. It provides a tool that replaces what takes nature between 500 to thousands of years to typically develop on its own, that top inch of topsoil, right? We can come through and bring in an imported material, this compost material, and immediately be achieving our soil building goals, our water quality goals, and reestablishing habitat goals. So these are really the three legs of sustainable erosion control works. So let's take a look at a couple case studies or a couple projects in Northern California. We're going to take a look at El Dorado County, or in El Dorado County, on Route 50 in South Lake Tahoe, and Route 89 in Emerald. Here, what about and the soil years of erosion, right? So, oh, go back, please. I'm sorry, listen, you go back with the slide. I don't know if that's picking up. No, you're going forward. There you go. Please hold there for just a moment. So in the Sacramento Valley, these are generally sandy loam soils. They're high quality soils eroded from the Sierra Nevada, and they're generally conducive to native plant growth. And if there is imported soil brought into projects in the valley, it's generally imported fairly locally because it's expensive to transport. So you're generally going to get pretty good soil in the Sacramento Valley. As we get up into the Sierra foothills, though, we start getting variable soil types as the geology has folded over and is overlapped over itself. Or maybe even just from historic imported roadside soils that were brought into this area, because as it becomes more mountainous, more imported soils were historically brought in. So some of these soils are conducive to plant growth and some not so much. And soil testing during the design phase is difficult to do, and it definitely won't provide any information on imported soils. So that's kind of a challenge as we start to get into the Sierra Nevada foothills. And as we get into the Sierra Nevada proper, all the way up into the high Sierra, we have mixed decomposed granite soils. Typically, conducive to plant growth, have a really thin O layer, which is typically removed during construction. And as I mentioned earlier, it can take thousands of years to develop. So both these locations had a very short growing season, 28 to 30 days in the summertime, up to 10 feet of snow standing on the ground in the wintertime, summer rain, freezing extremes in the winter. You can go ahead to the next slide, please. The first one we'll take a look at is El Dorado 50 in South Lake Tahoe. So this was a project, it was a stormwater improvement project, really, as well as a roadway improvement project that went right through the city of South Lake Tahoe, directly adjacent to the shore at the top of the picture there. The area outlined in yellow included a series of infiltration basins that were designed to take all of the stormwater runoff from the roadway improvement project. But what we found in that particular area right off the bat was the decomposed granite parent material just infiltrated water too quickly. And actually the design basin bottoms were simply actually too close to the water table itself. So we had to come up with a way to slow down the infiltration rate. So what we did for this project is we incorporated 3 inches of compost along with 3 inches of heavier woody overs into an 18-inch depth of the soil surface, and with the effort to try to slow the infiltration rate of the basins. And then compost was also used in the seeding application, erosion control seeding, as well as container planting revegetation efforts. Let's go ahead to the next slide and take a look at how this looks. All right, so 2011, the job was constructed starting actually, I believe in late 2010 is when they broke ground. Next slide, I have a couple pictures from 20. This kind of shows that there's a series of these infiltration basins that were carved out of this forested environment where we did some tree removal and chain these basins together. Go to the next slide. It's a couple, and so we've gone through a couple winters, a couple snow events, and the basins are performing. You can actually kind of see a bathtub ring kind of line there in this first of the series of basins, but not a whole lot of vegetation growth. There's a little bit there. The surface had our erosion control solution had an erosion control blanket along the top of it, and you can kind of see that amidst the vegetation. Go ahead to the next slide. Along the bike path, another infiltration basin. It appears that the vegetation's a little thicker, but again, you know, for being 2 seasons into it, it would have expected it to be a little point. You can go to the next slide. It had been a few years since I'd been up there, and happened to be up late last summer, and tried to include a few similar pictures here, and we can see how much it's and what I was encouraged to see growing in here was not just a monoculture. Getting some woodies, woody plant materials, some shrubs in there. We had some perennials as well as native grasses in that basin. There was even some containerized woody shrub material that was planted too. You can go to the next slide, please. And that's one of the more linear basins that we can see even from a distance. There's a pretty heavy vegetated stand there. And this was in August, similar to what Scott said earlier. You know, this is late summer in the Sierra, and granted, it gets probably daily, you know, was definitely a pretty green stand for being in late summer. So there's value to that compost in its water holding capacity characteristics. Let's go ahead and move to the next slide. Eldorado 89, Emerald Bay. So this project was a challenging project for me. This particular section of highway around Emerald Bay is typically closed in the winter time, and there's big metal gates, so they close it on either end, and the road's closed to avalanche issues around Emerald Bay. So needless to say, it gets a lot of snow. It's heavy snow load. It's a steep mountainous environment, and subsequently the roadside slopes. If we were lucky, they're 2 to 1. They tend to be more like 1.5, in some areas 1 to 1. So what this particular project was a widening to widen to standard shoulders, and so it pushed the road edge into both a cut slope and a filled slope. And as I mentioned earlier, it's this loose decomposed granite type soil with very little organic surface cover. And when the road is open in this area, there are winter sanding and salting operations, and that does compromise the vegetation in this. So you can go ahead and move to the next slide, please. So I came up with an idea that we needed to go ahead and do a site analysis of the site to assess the background cover. So this was an approach that actually our construction general stormwater permit has as an approved approach to show compliance with the permit, to assess your background cover, and then post-construction have 70% of your pre-construction cover achieved, and that will get you compliance. So this was a way we started using in these difficult environments to assess what our existing condition was. We really need to know what our target was, you know, to define achievable goals. And what we could really see here was that this condition in the picture, this 2 to 1 roadside slope, I was observing this failing TOA slope. There was salt damage on any of the living plants that were there. Physical damage to the slope face, antennae, the plant material from the blade of the equipment used to clean the ditch out. But then I also observed that in the woody vegetation further upslope, that the woodies were growing primarily in areas where there was organic litter present, right? Maybe these areas were micro flattened by rocks or tree branches or something that broke the slope down, made it slightly flatter, and then allowed some organic new pine needles and such to gather behind it. And lo and behold, there'd be a. So I started thinking, I wonder if I could replicate this kind of condition by incorporating woody compost into the soil surface. And if I could do this, then maybe I could rely on the background native forest to provide a long-term seed bank. And I could provide a short-term seed bank in my erosion control solution and be really working towards this natural succession, plant succession over time. So I worked with geotech, our geotechnical engineers, to help approach. We can move to the next slide, please.
3 minutes.
3 minutes? Okay. Great. So the treatment balances observations from the site analysis, from maintenance requirements, long and short-term stabilization goals. What we did here is core drilled these 12-inch diameter by 18-inch deep holes, 4 feet on center. We took the core material out and used a third of that parent soil material, mixed it with a third compost, third woody tub overs, and backfilled that into the holes. Put a 1-inch compost blanket over the top, a turf reinforcement mat over the top of that, more compost blanket into the turf reinforcement, and a bonded fiber matrix with seed in the top of it. And let's go ahead and move to the next slide, please. This project was advertised for bidding. And now we look at our picture where the yellow area is, and there's a big scar across the ground there. And lo and behold, construction was complete. There was a summer lightning storm and a wildfire, and it burned through the construction site. You can go to the next slide, please. The next slide, Jack. Yeah. So all we did was put another one across the top with some more seed. 6 years later, this site, you can see the fires burned through and taken the canopy. But along that road edge where the slope was laid back, there's quite a bit of vegetation growing. And it's not only bunch grasses, but there's some woodies growing in there too. Let's move to the next slide. So I didn't do a scientific breakdown on this and throw a frame over it and count the plants or what have you, but just by general observation, what I'm seeing is our herbaceous seeded material in that lower slope, below those lowest stumps. That's the section of the slope that was laid back. And there's some good vegetation cover. The woody shrubs are growing in right behind it. And I'm really, really hopeful. We can go ahead and hit the last slide. Oh no, maybe this is the last slide. There you go. And I'm really hopeful that we'll have very minimal, if any, sediment rolling into that ditch at the bottom. And if that's the case, then we won't have to take a blade in there and clean the ditch out. And we'll alleviate that, mechanical damage that's been happening along that slope face. So I'd be happy to entertain any questions.
Okay, thank you, Jeff. Appreciate that. So the first question is, you described on that South Lake Tahoe project that you applied 3 inches. You had soil that was too permeable, and you added 3 inches of compost, 3 inches of mulch, incorporated it to 18 inches deep. Correct?
Correct.
Okay.
So there was a question asked earlier to Jim when he was speaking, and around the time that a lot of these decisions were being made, the department was going through these changes. We were coming up with some to do this stuff and looking for opportunities and projects to do it. But there were, when we get into the issues like is it 3 inches of compost and 3 inches of parent, and what do the numbers actually show? The infiltrate becomes, when you do that. We didn't actually have those kind of numbers to work with, or those ways of calculating that. So there's a little bit of what have we done in the past, using some of the information John has mentioned, and others in the past, and just making the best decisions that we could, and then making our own observations and improving on that in the next project. So that's sort of what we're looking at here. Keep in mind, like I say, we're in 2020 now. The projects I featured, decisions were made on those over a decade ago, right? So.
Right. And so let me, there's an add-on question to that. So the question is, why was 3 inches of mulch added in the mix, which would tend to create pore space, and or was it an economic thing, or were you just trying to learn?
No, that's a great question. And actually that is a direct result of some of the research that Vic Clausen was doing with UC Davis in the early 2000s, that talked about, this is really early on. Before we even started, we're talking about even using compost or even incorporating it into these soils. And some of the research he did showed that having woodier material that would take a longer amount of time to break down, it would provide more organic content for a longer, more years, basically. So that's the value there. It was really more from a long-term, basically fertilizer aspect, right?
Yep, I totally get that. And in that same work, if I'm correct, because I reference it quite a bit, he showed that you could really grow some fantastic natives by using that coarse material, which maybe creates a little bit of a nitrogen draw, which gives the natives even more of an advantage over, nitrogen loving species.
Right.
Okay, so another question came in. Okay, you see 2 inches of compost, and you create this beautiful native vegetation for a year. The question is, are you having good success that it's coming back year after year, or are you having to reseed?
Yeah, well, typically in our projects, don't typically reseed once the project's out of construction, right? So that's why, as a designer, you got to do a really good job of knowing, what your maintenance, is going to be, so that you can design appropriately. What we didn't talk about over the last couple of days too much was putting compost down on the soil surface. It actually does build that soil. It improves that soil over time. So that 2 inches, yes, it's going to immediately provide value to the seed and allow it to come up, but it's going to be building the soil beneath it, so that as those plant materials are growing, they're able to get the roots down deeper, and essentially that horizon over that period of the next couple of years.
Yep. And I really think that's a key point here, because when we talk about using compost, 2-inch compost blanket or such, there are multiple things going on. We may be vegetating the area, but we're also building the soil long-term, and we're improving stormwater management on the site. So it's multiple things by putting that volume of material down. Thanks, Jeff. I appreciate that. And I'll pass this over to Brian to go to our last speaker of the day.
Thank you.
Thank you.
Dr. Sally Brown is a research professor at the College of the Environment at the University of Washington. She has worked identifying beneficial uses for biosolids and compost for almost 30 years. She is a fellow in the Soil Science Society of America and was a 2-term member of the National Academy of Science Committee on Soil Science. She writes a column for Biocycle Connect. Sally will discuss the Soils for Salmon program in Seattle and how it relates to Caltrans use of compost. Sally?
Let me see if you can see this. I want to commend all of you. You have spent 2 days learning that compost is not only making your life easier, there's nothing to feel guilty about. And so here's the view from up north in Seattle, where many of us resent you people from California because you've all moved here, but that I can also understand because I moved here from Brooklyn myself. Okay, so you're sitting on grass or you're sitting in traffic. What do these two things have in common? They look pretty dissimilar. And the next slide tells you one answer. Next slide. Okay. There are movies about each of these, excellent movies. And while you're not going to webinars, I would recommend highly, if you want to cry one or the other, this is not the answer I'm looking for. The answer I'm looking for, next slide, it's the dirt. On the sides of those roadways and underneath that grass, you're all dealing with soil, and the quality of that soil determines so much about your experience, okay? In each case, whether you're in your backyard or on Route 5 or number 5, your soils are a secondary part of the landscape. A lot of that landscape is impermeable, and so you only have a tiny amount of soil that you're asking to do a lot of the work. So we've been hearing this, soils on the highway and soils on your front lawn or parking strip are not dissimilar in terms of what you're asking them to do. And the next. Okay, and here, this whole presentation is going to focus on water. So what you can get that soil or dirt to do is going to be critical in maintaining water quality in areas that are not 1,000-acre forests where rain has very limited places to go, and you want to keep as much of it as possible in the ground so that when you go with your husband and the dog to the river, that river will be lovely, clean, pristine, and you can jump right in and not be terrified. Okay. Next. Okay. Washington State, everything we do revolves around salmon. Here is a king salmon going through the locks right in front of my house. And our job in the western part of the state has been drilled into our heads is to protect these fish. They taste excellent as well, I may add. Go on. Next. Okay, and because of that, there's a Soils for Salmon program. And the Soils for Salmon program, you can check out the website. It's all geared to protecting water quality so these fish have a better chance of surviving. And most of the focus of it, or what most people know about it, is it means that when you do new construction on a home site, you have to add compost. But it goes a lot further than that. And so here's some more examples from the website. Next. Okay, this may sound somewhat familiar. Why do you want to build healthy soil? For Soils for Salmon, so you can have more marketable buildings and landscapes. Better site erosion control. Sound familiar? Reduce need for water and chemicals. That might not be a bad thing if you're talking about roadways. Okay, less stormwater runoff, better water quality for salmon, orcas, and people. And so healthy landscapes, satisfied customers. And next. You can see on the website they have a range of tools available for designers and builders. If you look at these websites, you'll see that at the website and the tools that are recommended, you can apply a lot of this to a job as a landscape architect for a highway department, but you might also want to consider them for your backyard. What the main point of the presentation is, and let me re-get my charger so I don't run out of juice here, is that what you're doing for your road is to take care of its soil is the same thing that you want to do for your house, same thing that you want to do for your golf course, same thing you want to do for your park. Soils love organic matter, compost, easy way to get it. And next. Okay. We've heard a lot of stuff that as a soils person, I consider kind of icing on the cake. Mycorrhizae, native plants, different species, rooting depth, all these things, I want to bring it back to basics and a little bit of Soils 101 for a while. And that is to really understand the importance of what bulk density is and how it's just critical to understand why compost works so well for infiltration and erosion control. Bulk density is just how much the soil weighs per unit volume. So if you have a low bulk density, and that's what you're all aiming for, it means that your soil weighs less. Your shovel full of dirt is going to weigh a lot less than a shovel full of rocks, and that's your goal. Here's a low bulk density picture on the one side, and you can see all that pore space, and a higher bulk density picture on the right, and you can see much less pore space. That means there's no place for that water to go. So, next. Okay, here's some pictures of soil. This is right from when I teach Soil 101. Good condition soil, you see a lot of fluff. Roots coming in around sideways, a traffic nightmare, but fabulous for plants. It's great soil structure. That's going to be a low bulk density. Moderate, you could live with it, you'd rather not. And then the pore, you can see it looks like a slab of rock, and it'll weigh about the same as a slab of rock. It'll have a high bulk density. So your more pores in a soil, your larger pores, your more space for water, all mean lower bulk density, and that's what you're trying to get on your roadways, your right-of-ways. Next. Okay. When you reduce the bulk density in a soil, it means you make a lot of storage space in that soil. And when you have a low bulk density, that means that water can infiltrate quickly and it'll have a lot of space to hang out. Okay? And there's no magic in this. It's just you're making space for that water. And a great way to see if you've made sufficient space is by measuring an infiltration rate of how quickly water flows into soil. And so we can get the next. Okay. If it's raining really hard or even raining really light and you're trying to pour that rain into concrete, the infiltration rate is going to exceed, or the rate of rainfall is going to exceed the infiltration rate. And that means your water is going to have to go someplace, and it's typically going to go over the soil surface. It's called overland flow. And very often, especially when it's raining hard or there's a lot of rain, when that rain is going over the surface instead of into the soil, it's going to carry soil with it. That's erosion. And as fans of muddy waters would recognize, what's great for the blues is not good for the soil. Next. And here's a picture of it happening. If you're a poor, pitiful piece of soil and that rain comes pelting down, think of being in Louisiana or Texas right now, and that's an extreme and unfortunate thing. I bet you would like a few inches of that in California and be happy to take some of that off their lands. But you get that detachment and that transport, and that means erosion. We've seen numbers and numbers of pictures of erosion in the last couple of days with this. Okay, and then we go to the next one. You get that erosion in an extreme event, and this is what you get. And you can go back to the muddy water picture. This is not what you're looking for. In fact, this is what you're trying to avoid. Okay, and next. That was a bad joke, by the way, with the muddy water pun. And so I'm hoping that some of the people that are listening are laughing at the bad joke. I'm working hard here on some bad humor to get you through this. Okay, here's some examples. The bulk density of a rock, if you're holding up a rock and you measure its bulk density, it's about 2.6 grams per cubic centimeter. And here is community garden in Tacoma. And remember, what works for your community garden also works for your highway. We took a biosolids-based soil product to control soil, which was pretty nice to begin with, about half as dense as a rock. And we cut that in half again. So you're talking about a very light, fluffy water that'll let as much water, rainwater, soil, that'll let as much rainwater soak in as comes down, and do it really quickly. Another example here from another community garden, very light soil, nice soil to begin with, but again, we reduced that bulk density in half. And then if we go to the next one, you can see infiltration rates. Now here's a guide for good infiltration rates, and you're talking about greater than 0.8 inches per hour. With these composts, we're getting 200 plus inches an hour. So a little bit of very heavily compost amended soil can do a lot of work, because it's very rare that you'll get a 250 inch an hour rain event. I think that's called being in a lake, a 250 inch an hour rain event. Lakes are lovely, refreshing, but you don't have to worry about those. What I'm saying here, though, is you want a rapid infiltration rate, way more than a regular soil can provide. Use a lot of compost. And it's because you've reduced the bulk density. Next one. Okay, how to get some car references in here. You want to talk about high performance and rapid acceleration or infiltration. Compost for you is the same thing as a Lotus, but at a very, very small fraction of the price. Not too shabby. Okay, next. Okay, I gave you the bulk density example for community gardens. Let's take it to a highway. One that was worked on by Washington State University outside of Tacoma, Washington. The bulk density here from the very nicely smooth and shaped surface area, and a lot of the people that work on highways are used to thinking that you want everything even. Soil is the opposite of that. You don't want to run a lot of equipment on it and reduce that bulk density. Here, that message didn't get across. So it was 2.2 grams per centimeter, or essentially they'd taken that subsoil, turned it into rock. Adding 100 to 150 tons per hectare, especially incorporating it in, you reduce that bulk density in about 10 minutes to about a gram per cubic centimeter. And you're going from a Ford Pinto there to a hell of a lot closer to a Lotus. Okay, next one. Okay, here's some souvenir photos, some travel photos. You've seen plenty of these from California. Here's some from WashDOT. Here's erosion where and you can see those rills where the compost was not applied. Another that compost works even up north. Here's another example from WashDOT. This one is far from Salmon. It's on the eastern side of the state in Spokane. Very fine sand, compost applied in 2005, and where instead of compost you had seed mulch tack fire, heavy rains. You can see those rills again, and you can be sure that somebody was singing the blues at the base of that hill. Another bad joke for you. You can thank me later. Next picture. Okay. So compost, if you haven't listened, if you listened for half an hour in the last 2 days, you know that compost works really well to reduce erosion and increase infiltration. Next part of this is to say it also works really well to remove contaminants from that water that's eroding. And so we're going to start here. Again, what works in the backyard also works on the highway. A big program in the Seattle area with the Soils for Salmon is C Streets. And it's taking the soils in front yards and the parking strip and working them to have more compost and sand so that the rain can infiltrate really easily and you can reduce flooding in city streets. And it looks really pretty too. Lovely, lovely gardens and parking strips. Next. Here's a picture that I stole or was generously loaned to me from an earlier presentation. Same issue that is asked for you to do roadside wise with NPDES permits. You don't want any contaminants carried in rainwater leaving the site and eroding into or flowing into lakes and streams. So in your swales, one of your big issues is to have not only rainwater absorption, but contaminant adsorption as well, rainwater infiltration. And next. Okay, so we did a study. Julia J. and Megan Plog were the students on this, and that is one of the floating bridges. That's the 520 bridge. in Seattle, and we took stormwater from that and measured changes in metal, PAHs, polyaromatic hydrocarbons, turbidity, and nutrients through a wide range of different mixtures of compost, some made with food yard waste, some just with yard waste, a lot with different kinds of municipal biosolids from wastewater treatment. And does it work? Next slide. Okay, we used high iron biosolids for this, and we used it as biosolids and composted with wood waste. These mixtures, you pour that highway runoff through it, 100% of the cadmium's gone. 92% of the chromium's gone. Wasn't any lead to find. We got all the lead out, and about over 90% of the zinc was gone. So metal removal from these was fabulous. Next. PAHs. Here's Megan pouring some of that roadway runoff through our bioretention soils, and no vegetation necessary for these guys to work. Here is an illegible picture of the different pHs that we tested for and their concentrations, and we can go to the next one. And the lavender line is what was in the effluent, and the darker purple line is what was coming out the bottom. Basically, we got excellent removal for all the systems. The biosolids yard and the biosolids yard compost with water treatment residuals added took them all out. So complete removal of PAHs. I can send you, anybody who's interested, science peer-reviewed paper on this study if you'd like. But take it from me, this stuff worked pretty well. Next. Okay, the one issue we had, and this is a little bit of a complicated graph here, but the biosolids-based composts, which are used very heavily by TxDOT, can be nutrient-rich if you take them right as they come, which is great for your backyard and not so good for your highway or your stormwater system. So what is really good to do here, and what this shows, and I don't know if my pointer will show up here, but if you change the C to N ratio by taking that biosolids and adding more yard waste to it, you can, this is an extreme, but we added a lot of sawdust to here, and that nitrate here disappeared completely in that last part of the bar graph. So nitrate and nutrient movement is something to think about, but especially if you have a lot of the compost that people have been talking about won't be a concern. We were testing really rich stuff here. And next one. Okay. One of the things with bioretention soils, and yet another bad pun on the highway end of it here, is there's concern with the regulators that if the water doesn't hang around in the soil and infiltrates too quickly, you won't get the level of contaminant removal that you're looking for. And so we tested whether there was any relationship between metal removal and contaminant removal in the study that we're talking about. And we found basically that it was a mess. There was no relationship at all. So in other words, putting it in the roadway context, take that speed limit, forget about it. That water can go through as quickly as possible. And I showed you that 250 inches an hour is well in excess. So that's another thing that's really lovely about these compost amended tools to clean your stormwater. Next. There was discussion earlier this morning about carbon sequestration, and this is a different paper. Happy to send a reprint on this as well. But we measured changes in soil carbon after this compost was put down on the highways. And we just recently had a paper that included that data to do a full carbon accounting on compost use in urban areas. And let's say you get that compost delivered in a 5-ton truck. It has a certain amount of carbon emissions associated with driving that truck. We found, especially on the degraded soils that are so typical of roadsides, for each ton of compost you apply, you get over a ton of soil carbon accumulated. In addition, that compost can have fertilizer value, and fertilizers cost a lot of energy to produce. So you get a fertilizer credit as well. In other words, for each ton of compost you apply to a roadway, we've published and modeled that you sequester more than a ton of CO2. And if you do it on the basis of a biosolids feedstock to make that compost, it's about 0.7 tons of CO2 per ton, and these are dry tons of biosolids. So you can feel really, really good about this. Happy to send papers again. And next one. Okay. So compost, think of it this way. It's your Tesla equivalent, again, at a tiny fraction of the price. I've been told, I haven't driven one, but I've been told that these are fabulous to drive. It's a very versatile tool, compost, and it's your best tool available for multiple purposes and multiple end goals of your project. And the other thing is it's much, much better than carbon neutral. It's something that gives you carbon credits. So next. Okay, last slide here. This is my father-in-law who was catching salmon when I was back in Brooklyn and didn't even know what salmon were. I was big on bluefish growing up. Whether you're talking about urban areas or any kind of areas where there are pavement, asphalt, and concrete, so that's any highway, whether you're in the middle of the city or middle of nowhere, you're counting on that soil to take care of not only the water that's coming and falling right onto it, you're counting on that soil to take care of a lot of the water that's falling on the impermeable areas all around it. And soil is a natural system that is really good at, if it's treated well and has enough organic matter, and the way you get that is with compost, it can do at a fraction of the price of an engineered system almost anything you want it to do. So whatever kind of system you're talking about, whether it's your backyard, your park, or your roadway, compost is just your easy answer that you don't, it's not cheating. You don't get penalized for this. You get praised for this. And so that's the end. And any questions, I'm happy to take a stab at. Thank you.
Well, thank you, Sally. That was wonderful, and I'm glad that your cheesy humor has not degraded over time. And I'm just going to throw it in because it hit me right away. You were showing a king salmon going through locks, and I realized if you smoke that salmon, you turn it into lox. LOX.
Yeah.
All right. We'll move that. We'll move on to real
tit
questions.
for tat there. Okay.
Thank you. And by the way, that was great information on the addition of sawdust, and also the addition of iron to different mixes to basically help manage what may be considered pollutants or the migration of pollutants. So thank you for that. The question came up: what is the C? Is there a CN ratio you're looking for in a compost that could reduce the amount of nitrate export?
And you know, Ron, you're probably better at answering that than I am.
Yeah, well, and I'm going to say I'm not sure there's great research on that, but as a fallback, Sally and I have both done a lot of work with biosolids for many, many years. But I do see that there's always a fallback when it comes to nitrogen movement, and that fallback is using green waste compost. But it is important to know that these aren't simple questions. Things happen when you incorporate materials into the ground, and if you get vegetation up. I think, Sally, you guys have done work out there with grad students. You get that vegetation up, and you could reduce any potential nitrogen movement.
Yep. Yeah.
So
Roadside. Yeah, and most of the composts that I've heard people talk about are going to be 14 to 1 or higher. A lot of the biosolids compost and some of the biosolids we were using was 9 to 1 to 12 to 1.
Yeah. That's
So
really high.
Yeah.
Really, really high. Okay.
Really rich material.
Absolutely. I'm going to ask another question that actually came in yesterday. It's perfect for you on this. So I know that you guys have done a bunch of work in biofiltration studies using compost. And of course, a question came up. There was a speaker who showed a few examples of biofiltration yesterday. We establish our vegetation. That's great. We have the compost in there that helps that. But what are the concerns? What are the realities of nutrient movement from those media?
And again, in this, so one of the things that you have to realize is that you've increased the water holding capacity, and and we've seen this all day today. You see that the plants are still green long after they shouldn't be. So the plants are using that water. The plants are using those nutrients. So what's been seen in Seattle in the C Streets program is you eliminate the amount of water that's actually leaving a site instead of just hanging out in the soil is minimal. Okay, so you've reduced the quantity of water. And so with that, you've reduced any quantity of nutrients. What can I say? So that's been something that people don't tend to think about. The volume of discharge is so reduced that the actual if the concentration of nutrients may be higher, they're dealing with 1 quart instead of 50 gallons worth.
There you go. Well, yeah. I mean, I think that is what the science has shown us. And there were a couple questions yesterday that we may get back into again later, but the same question came up when it came to compost blankets, and something very similar occurs, right? We have a lot less water leaving the site.
Yeah, and that's what's been seen in WashDOT repeatedly.
Right. And Sally, do you want to make a comment also? Something that WashDOT does that I find very, very interesting, and they were the groundbreakers on this. They incorporate compost on the sides of the roads to help to deal with a metal content in stormwater.
Like I showed some of the data on this, you get really excellent metal removal, and we published a bunch of papers on this. There's a fixation in Washington for the salmon about 0.5 ppb, parts per billion of copper. And there's also been research to show that that's unnecessarily low. Nevertheless, metals have been a big focus, and the compost has done an excellent job. And again, you're dealing with a quart instead of 50 gallons.
Right. So one of the questions that came up here in some of these media that we're creating with compost and soil, are there specific toxins or contaminants? What are the major groups that are being captured, and do we know if it changes over time? Does efficiency go down over time?
And again, this was said earlier today and not by me. You're building a healthy soil, and a healthy soil does amazing things. So each year, as you get a stronger and stronger soil system, that's the synergy. And we heard the soil, plant, water. We saw that diagram earlier. You should get better. You may get reduced infiltration rate over time as you get some sediment deposition. So there's 2 ways to look at that. One is add some mulch to the surface, and you're doing good. Another is, how much does it cost to redo a bioretention soil system with sand and compost versus putting in an engineered system? And you're talking about spending 50 cents versus $5 for the engineered system. These are just relative costs. So this is a new approach that's mimicking natural systems. I can't tell you what it's going to look like in 50 years. I won't be here, so don't come asking. But everything we know suggests you're going to be fine for a long time, and even if you have to tweak it, it's not a big deal.
Right. And I have another question here. And Sally, we've had these discussions about metal removal efficiency with compost and stormwater. Can you name a couple studies? Somebody was asking information on studies. Are there a couple that you can name off the top of your head if somebody, whoever asked that question, may want to scribble them down?
J et al. I'm on that one. Julia J et al. The study I talk about. We did another one that's Brown et al. That's me, and we have a bunch of references in there to other studies. So if Jack asks me, I will send him reprints, and I'm sure he can get those out. And that right now, Jack is cursing me.
Yeah, it's a good answer. Yeah, we all like that though. So another question, a question came up. You showed in one of your slides a 60-40 mixture of compost and sand used in a garden application. What was the application rate? Was that actually incorporated into the soil, or was that placed on top?
That was the soil. That was that replaced the soil, and that's how the C Street system to build rain gardens works. You replace the soil with that. That's a by volume mix, so it's about a 10% compost by weight.
Gotcha. And then what's the depth, Sally, if you recall?
I don't recall. Okay. But that's why I put that C Streets or Soils for Salmon website in the talk.
What she just said is look it up yourself, is what I just heard her say.
Yeah, I don't remember.
Yeah, fair enough. And what can you say about herbicide residuals in compost products overall?
There was a big deal in Washington State and I think across the country with clopyralid, which I bet Ron could talk about for an hour. But in general, that got banned pretty much, and it hasn't been much of an issue. It's not something that I've ever lost sleep over.
Yeah, fair enough. And we could maybe talk about that later on if we have some time. Let's see here. And I think that was the last question.
Okay.
If we can round it up, and then Sally, I know you're going to hang around, and and then I'll pass this on to Jack. And Jack, I've compiled a bunch of questions. Just tell me how you would like me to do this. I have an idea of who I'd like to direct different questions to. Just let me know. Thank you again, Sally.
Sure. I'm gonna take my headphones out for just a second, but then I'll be right back.
All right.
Honey?
Sally, let me mute her. There we go. As all the speakers are going to be unmuting themselves, I'll go ahead and make an introduction on this next session. Ron, you've done an excellent job with us to keep this on track with the questions. We've got, I want to say it's in the neighborhood of 30 to 40 pages of questions that have come in from you, the audience, and been fed up to Ron. And live time, real time, Ron has been trying to filter those up into pertinent questions of each of the speakers. So now we're challenging Ron even harder at his job to handle all of the questions that have come in and filter them up to this panel discussion session. So Ron, you're doing a fantastic job. Let me turn I think my camera's on. Yeah, it is. And we'll keep you challenged. Our next session here, it is the end of the compost workshop session. We've got a panel discussion, and it includes Neil Edgar, Dr. David Crone, Dr. Britt Fawcett, Mike Farrar, Matt Cotton, Jim Phillip, John McCullough, Scott Dallin, Jeff Peterzak, Dr. Sally Brown, and your host, Ron Alexander. Brian Larimore and myself, Jack Broadbent, will also be available if you guys have a good question that might stump the panel, which I we'll see if that actually can happen. They're very adept at what they do. Then Brian and I could jump in as well and see if we could cover some of those questions. So with that, Ron, I will turn it over to you. Thank you,
Okay,
sir.
Jack, I'm actually gonna, and by the way, thank you for thanking me, and it's really good you guys have a low bar of skill. I appreciate that.
Hey, Ron, before you get started, let me introduce you because we haven't done that yet.
Oh, we haven't introduced. Yeah, thank you, Brian.
So Ron Alexander is a horticulturist by training and has worked with the California landscaping industry for over 20 years. He possesses over 35 years of experience working with organic recycled products and landscaping. Ron has developed both national specifications, including for the American Association of State Highway Transportation Officials, and California specifications for Caltrans, use of compost in landscaping and soil management. He also managed the National Compost Quality Program, U.S. Composting Council Seal of Testing Assurance Program for 10 years. More recently, Ron has been working on compost and stormwater management and water efficient landscape applications in the Bay Area. He is also a landscape architecture continuing education system certified trainer. Ron?
Okay, well, thank you for that. And may I mention that I do not run the STA program. I did the initial project in 2000 and ran the program for 10 years. Then they booted me out the door. They were a little tired of my bad humor. So, so that wasn't really true. But Jack, I do want to ask you a quick question to start it off before you jump. A question was asked: is there a CT deputy initiative or policy memo regarding the use of compost with Caltrans?
That's a great question. We were just talking about that earlier this morning with the group. There currently is not one. We do have several different bits of legislation that tell us to use compost and get us to report the volumes of compost that are being used across the state. But as far as like what we have is internal policy and deputy directives, things like that. We don't have a policy written on using compost. We do have information and standards, and you saw Mike talk about the standards earlier. And we also have information in what we call the Highway Design Manual to get toward the best solution for a project for erosion control and revegetation. So the short answer, no. The long answer is yes, we have lots of other pieces within the department that direct us toward that direction.
Okay, and this next question is going to go to Mike. And thank you for doing the timing today, Mike. I appreciate the help on that. Question came up yesterday, and I think it may have come from actually another state DOT, but the question is, when compost is being used as a blanket on the roadside, are you typically requiring a guar tackifier, and if so, at what application rate?
Well, actually, that answer might be better from a designer. We do have guar as an option, but there are others. So I don't design anything. Maybe one of our designers, Scott, could answer.
Yeah, I can go ahead and try to answer that. So yeah, we typically do apply a tackifier and hydromulch over the compost just to tack it down and keep it, with a lot of vehicle traffic that creates, kind of these little wind tunnels, it tends to move the compost. So by tacking it down, we eliminate that issue.
Okay. Is there an application rate, Scott?
I might add that the industry standard for guar for a hydromulcher is around 90 pounds per acre. Comes in 60-pound bags. Have a lot of success packing straw, like with guar, like a hairspray. If you want a long-term straw mulch, or walk on it for a long time, you could go 120 pounds per acre of guar. That's the industry standards.
because it is going to wash away over time. And Brooke, do you want to throw anything in there? I know you did some interesting work way back with the use of just straight tackifiers. I think not hydroseeding mulch and blankets, right?
Definitely always used it with hydromulches and straw, tacking down straw.
Right. Britt, anything you want to throw in there?
I have done some work at San Diego State University looking at it. I didn't look at guar as a tack, but other types of tackifiers that are made for mineral soils, and applied those to the compost blanket. And it actually didn't work that well. I could see how it would work well for some wind conditions, which is not what we evaluated. Obviously, just intense rainfall conditions. And it just took an inordinate amount of the tackifier to see a stability benefit because of the porosity and the high surface area of the compost. And then after that, it actually reduced its absorptive capacity. Now that was probably because it used so much to get that stability. And let me stress that this is tackifier made for mineral soils, not for.
I'll tell you what, one of the things that came up during the meetings over the past 2 days is using compost in windy conditions. And I'm thrilled Scott showed some real success on doing that. But I do not know of a lot of actual university study on that subject, and we probably need to do more work on it because it is going to change the way I think we use the product. But I'm really glad that Scott showed that it does work. But I would venture to say that we need more research there. David Crone, Dr. David Crone, my North Carolina brother. They kicked him out, but they took me in as a trade-off, and it was a bad trade.
Ron, I don't know anyone else who's better at being both pertinent and impertinent at the same time.
My family has said the same thing to me, and a lot worse. So a couple questions came up during the discussions about composting process. One of the questions is there a simple, can you give a little bit of comment on how long the curing phase typically is in a process, and overall, by average, how long it typically takes to make compost?
It really varies considerably depending on the technologies that are being applied, depending on the feedstock. So yeah, I would really hesitate to say that. Generally, I say that the active phase takes weeks and the curing phase takes months, but on the short end of months. But some people, it can be like 4 months. Usually it's weeks for the active phase, short end of months for the curing phase. But it really just depends. And the thing to do is just test it, see if it's ready.
Yep. And one of these questions had to do with pathogen destruction, and even you were showing a watermelon seed picture yesterday, and basically the destruction of those materials happens within days to weeks, correct?
Pathogens?
Pathogens, and then maybe even watermelon seeds.
Yeah, if you get above 131 degrees, the idea is it takes 3 days to reliably inactivate pathogens. Watermelon seeds, I don't have data on.
Yeah, there you go. Good answer. Spoken like a true scientist, you didn't venture a guess. Sally, you got a question about watermelon seeds or another kind of seed?
Unmute. Okay. If you get time and temperature for pathogen kill, you also get time and temperature for weed seed destruction. Right. And I think the time and temperature regs are pretty much ubiquitous in California for composting. So you just make sure, and then you ask Ron if it's STA certified compost, and you'll have met the time and temp requirements.
And that is really something, John, I'll jump on there in a second. That is really something that we've typically gone by in the STA program. Most of the national testing programs do not test for weed seeds because some of the tests are so dependent on scale that it's so easy to be inaccurate. So we don't test for things like that or bulk density typically in standards because it can be quite varied. The only weird seed that I've seen that lives in compost, and I was told this by a Californian, if you don't screen some of those big massive palm seeds, I bet you they could get through the process, but temperature is pretty high for an extended period of time. But John, did you want to throw something in there about weed seed inactivation?
I know we're talking about the stability of compost. It's something I didn't get to mention in my talk. Back in the day, I was working with Donald Gray, a preeminent geotechnical engineer, University of Michigan. He had his students, for instance, measure the tensile strength of roots, every kind of root you can imagine, and the pull-out resistance of grass roots. So the point made is when you plant in a soil, you're adding tensile strength to the soil with those roots. Anytime those roots are 90 degrees to the failure plane, you're adding strength to the soil. And he said, one day, John, we're going to find out that microorganisms are going to produce stabilized soils in a way stronger than concrete. And I think we're at that point. I think when you start realizing, and I'm getting to the point that curing, in my mind, is one of the most important things we can do for having stable, and not just stable compost, but stability in the soil profile. The ability of it to fail and run and not absorb water comes from that curing time. If you think about it, we'll end up with bacteria and cohesion. We end up with bacteria and mycorrhizae and hyphae in those composts. All of those are adding tensile strength to the compost. Add to that we apply the compost pneumatically. We blow it in the air so it's perfectly loose and fragile, and it allows maximum infiltration rates. And then we have humic acid being developed, which adds glue to the soil. Those are the things that make the compost. And the reason I'm seeing it in contrast, when I see compost being used, so-called compost, that doesn't have the certificate or has very short curing time, I notice failures. And so I just want to say there's some inborn, inherent internal areas of friction, if you will, that go with the compost. That's very important.
Yeah, and I think it's quite interesting you mentioned that, John, because I wrote a paper. I dug up some information. We've been testing compost, different composts for humic substance content, and we're finding a substantial volume in compost. And there is a trend. The older the compost, the greater the humification. Typically, rates go up. And I published a paper recently. If anybody wants to go online and Biocycle Connection on that just a couple of weeks ago. So I think that's an interesting one. John, while you're talking, let me throw another quick question at you that came in while you were speaking. And the question came up yesterday is, will an organic fertilizer used in native plant establishment be better than a commercial fertilizer? I assume they mean inorganic fertilizer.
Yeah, I'm of the belief that if we use compost, no fertilizer is best, at least. And I'm familiar with California natives. Okay, but those natives, how is it that a native grass or a grasses in California pre-humans could withstand 8 months with no rain? How were they able to adapt to stand that? And I believe a lot of cases it's the relationship with the mycorrhizae. So
okay.
Yeah.
Jim, are you still out there? Yep, I see Jim. Okay. Hey, Jim, a question came up with your presentation on your biofiltration mechanisms or features, I guess I should say. Are you, but when they're used, are you typically having to incorporate irrigation into the system, or is there a way to get away from that? That means Jim is muted or he's taking a potty break. Jim, you there?
Jim? He may have stepped away from his desk.
Okay. Anybody else have experience with that though in a California situation? I know in the Bay Area we got big old concerns keeping plants alive in bioretention soils because they're so droughty. Anybody want to give any input on that, Brett?
Scott, do you want to take a shot at that?
Yeah, I would imagine, given the dry climate that we're in and the duration between natural rain events, is that most plants, that we're expecting to grow in a saturated condition in a biofiltration situation to handle those saturated times is going to probably need some sort of supplemental irrigation during those long dry periods. So I haven't built those specifically myself, but that would be my expectation.
Britt, what's your experience on the projects you work with?
I would say it's possible, but one of the nice benefits of the inclusion rates of compost, even higher inclusion rates, is the ability to hold moisture there when it's lacking. So getting it through that drier period, really, honestly, not unlike what John described when utilizing native plants in the California landscape. There was irrigation.
Yeah, and I think people have to realize too, we're building systems that filter and move water off the surface, and we're trying to get the best of both worlds. This is not an easy answer, I'm afraid.
So Ron, let me cover a little bit of that from a statewide perspective on what I've seen.
Sure.
Matt or Brett, I think there's some feedback coming from one of you guys. So what I have seen in the northern part of the state, typically we can get away with building a biostrip or bioswale without doing irrigation. As you move down toward the southern part of the state, specifically down toward San Diego, San Bernardino, those areas, I have seen our landscape architects do permanent irrigation to biostrips and bioswales to keep the grass green. One of the requirements we have here with our NPDES permit is, as Scott had mentioned, and I think even Jeff had mentioned, our goal when revegetating is 70% of background for revegetation. So if you're in a desert, you only have to get to 70% of what that desert site looked like. The difference with a stormwater treatment device, a strip or a swale, we have to get to 70% vegetative cover. So therefore, in order to do that out in a drier climate environment, you're forced into an irrigation system. So we've been trying to work around that and use different techniques and different alternatives so we don't have permanent irrigation for water quality treatment devices. So there's been a blend, and in some cases, for example, District 7, which is our Los Angeles basin, they use a temporary irrigation system. So they put the landscaping out there, the biostrip, bioswale. One case in particular, it was a nice stand of deer grass that they had put in and used temporary irrigation to get that started. A couple years later, turn it off, abandon the irrigation system, and then the natural systems take over. So that's been some of the different approaches. As Mike had shown in his presentation, we are an extremely diverse state. So some of those questions can't just be answered with one answer.
Yep, I think that's really true. There was a question that got popped up that it's a little bit of a loaded question, but I'll throw it up there to some of the people who worked on the compost production side. Is there an ideal CN ratio for the use of compost in these BMPs? So I could go on that one, but I'm gonna throw it up to the group there.
I think it depends on the use, but I'm gonna go back to I want to answer the weed question a little bit more. We looked at heat, and heat without composting and heat with composting on a number of weeds, and it really it's not the heat, it's the compost environment that really knocks back the weeds. And 3 days is normally enough. But if you compare, say, holding it at 131 degrees without compost, clover and tomato did nothing. You put them in compost, they get knocked back. Now, after 3 days, we still have, tomato was eliminated, we still had some clover left over. But the curing environment still has that environment. So I don't think it's as much of a concern. Some weeds are recalcitrant. Most aren't. You're going to get much, much better weed control with something composted than something that isn't. As far as the ideal carbon to nitrogen ratio, what are we talking about using it for? I wouldn't want to generalize.
Right. And I do think that there's one big problem. I just want to bring something up when people ask that question. It seems like it should be a simple question. And I would tell people that when you have a screen compost, if you're under 20-1, that's pretty darn good. Now, here's the problem. The way we test compost, we screen the coarse particles out of them. So if we have an erosion control compost, we don't grind up that wood where the CN ratio, you would look at that mass, would technically be higher, but that's not the way it's tested. So it's not a simple question to answer, just because of the way we test the material. Somebody did ask a question, and this is an interesting one, on the suitability. Is there a specific suitable compost for use in desert environments? Little bit similar. Does anybody want to go after that one?
I will. I'm not a designer, but I can tell you as a contract person, the most suitable is whatever is available. It's going to be far away, at least where we are. And again, the transportation costs are still a real big issue when we meet with the contractors. So if you're in a real remote place, which typically our deserts are, it's whatever's available.
That was not the scientific answer I was looking for. So, John, I saw you wave your hand, and I'll jump in at the end. Go ahead.
Well, anecdotal also, sorry for that, but working with my friends in Australia and New Zealand that are doing a lot of compost, for a long time in the dry areas of Australia, they were using a wetting agent. A couple of big contractors were applying wetting agent to the soil and applying a little bit to the compost after it had been applied. And that would get it through, trying to stop it from drying out and getting that hydrophobic, kind of a dry planting pot kind of situation. And then I talked to one of he's got 7 trucks and he's doing this in Australia. And he said, you know what, John, I stopped doing that. I started making sure that I got compost that was cured properly, 2 months cured, and I didn't need to worry about it drying out and desiccating. Again, that's just hearsay information.
Right. Yeah. Well, I think one of the questions that people want to know about compost use in desert environments, I think part of it has to do with what are you growing? And if you're growing native plants and you want low nutrient content, then we can deal with that through the compost we purchase. But I'm not sure if there have been great studies done on taking a super stable compost, high humic content, versus a coarse compost with a lot of wood in it, and which lasts longer in the ground. I'm not sure I've ever seen a university study on that.
Yeah, and just to add a little bit, when talking to the different manufacturers across California, they get what they get for source materials. For instance, some of the people down south San Diego area can really give you reams and reams of information on what to do with palm fronds, for instance, and how difficult they are, and which is not an issue as you go further north in the state. So yeah, the source material really will drive a lot of it too. And this idea that you can, at least based on my experience talking to the manufacturers, that you can make boutique type compost, from manufacturers who make a profit by selling by bulk. I mean, you have to really analyze the practicality of that.
Scott, I have a double question for you. Are you prepared? Are you sitting down? Oh, you're sitting down. Good.
I'm ready.
All right. It really isn't that big of a deal, but two questions for you. What is the maximum slope percentage that compost can be used before you see erosion begin on slopes? And I just want you to remind everybody what you found.
Yeah. So, I have a project where we installed compost blanket on slope lengths of 150 feet, and we took off all linear sediment barriers, and it performed fantastic. We did have a netting over the top to help hold the compost in place and protect against erosion. But I guess let me just, the question is how long of a slope length?
I don't think that there's not great description here on that, but my question would just go one step further. When do you start putting netting? When do you start using netting along with compost on your projects?
Okay, on 2-to-1 slopes, or again, there's so many variables. It's hard to tell. Like for example, the Big Sur project where we had 1,000-foot slope length at a 1-to-1 slope. That was a very steep, long slope length, and what I would consider aggressive. We need aggressive erosion control, and we just did topical application of compost with no netting. So,
no, there was no netting on that one.
No.
Wow. Okay.
Yeah. So I think what's happening is we keep pushing our comfort level. We started to use compost and say, well, as an insurance policy, let's put some netting over the top. Let's do some other mechanical erosion control methods to as an insurance policy and protect our investment. But then as we keep using it, we keep kind of peeling things off and discovering, oh my gosh, wow, the compost is still performing without doing this additional things. And I think the difficult thing is on large scale projects, you don't want to tip the balance to where you pushed it so far that you've found out that you had an entire slope fail. But we keep pushing the boundaries and finding phenomenal results with just pure compost.
Okay. There was a question that was also asked when you're applying BFM and compost blankets, which do you apply first? I'm assuming you're applying the compost first.
Correct.
Okay. Now the next question is, when do you use that together instead of just injecting seed? Is there a reason why that you would use BFM over compost blanket?
Yeah, that's a great question. In fact, those slides I showed, we never intended or specified the use of BFM over compost. That was a decision that was made in the field by the contractor. They were actually in the process of applying permanent erosion control, and they had applied compost on half the slope. And then a storm event was coming, and they were required to cover all disturbed areas with soil protection. And they just assumed, well, if I'm covering the exposed soil, I'm just going to, not knowing the properties of compost, that actually is a BMP in itself. They end up covering the whole thing. But we never specify the use of BFM over compost. We do specify hydroseeding.
As a pack.
With pack, but at really low rates. And I think that was mentioned by somebody, really we're using the tackifier and the wood mulch or the hydraulic mulch to really carry the seed. That's a way to get the seed onto the soil. So.
Okay. John, you wanted to throw something in there?
Yeah, I just wanted to mention it's again, and Scott mentioned it's not really an industry standard to add BFM to compost. And I want to reiterate what I suspect one of the ways, if we're going to want to start adding tack to compost, we need to incorporate it into the compost. And that's why I mentioned that micro blend. You put it in the hopper, and the hopper feeds it into the machine, and the machine mixes it. So it's internally added to the compost. I think that makes a much better idea. We're, as Scott mentioned, we're kind of risk aversion. So if it gets kind of hairy, let's start adding more and more BMPs to it. And we're finding that it's not really that necessary. So that's not a typical thing to add BFM to the. You have two of the most expensive, and these BFMs are very expensive. You have two of the most expensive Cadillac versions you're actually putting down, and then you're just doubling your cost.
Yeah, I think that's a great point. Brett, I want to shoot back. I got a double question for you here. The first one is, when you're leaving a sock on site, how long does it typically last before you have to look at replacing it?
Before I answer that, I'm gonna add on to what John said. And when you add a BFM on top of a compost blanket, in many cases, you're negating the great benefit of what the compost blanket provides by basically sealing it off. So that absorptive capacity that you get in order to prevent runoff, everybody's been talking about the last few days, you begin to prevent a lot of that from occurring. So you're actually taking that away from the best benefits of the compost blanket. So I would discourage it. In answer to the question about the sock, it really depends. So if you, and it depends on the application. So the compost sock itself, and we've seen some examples of this, can last for at least a couple of years in the landscape. If you add vegetation into the mix, it's going to become a permanent treatment type system. One of the reasons why we want to use compost here instead of a mulch material is that that organic is more stable and it's going to last much longer for you. If you're using it in a temporary application, and this is going to be true of all types of sediment control BMPs, you're going to want to remove the sediment when it reaches half the height of the device to continue to allow it to form and function for a longer period of time. So, and some folks will even use these systems for short-term post-construction stormwater treatment without vegetation on industrial sites or even MS4 sites. And those can be pretty short-term applications if needed, but they can last quite a while. So it really depends on the application.
Okay, and then I wanted you just to go over something, and Sally talked a little bit about this when she was talking, but somebody asked a question yesterday and they sent it back today. That usually means I did not ask that question, so I will ask that question. And the question has to do with, I think this comes from people's disbelief that this stuff stays on a slope and what it does. And you and I were talking about that recently. It's a little bit counterintuitive to people's brains a little bit. But the question was asked, when you apply this stuff to a bare soil and it becomes saturated during a heavy rainstorm, what prevents sediment migration and what prevents nutrient leaching from the media?
So after it reaches saturation, and let me say, this has been a theme throughout, it takes a lot to get to that point. So, when you're comparing it to other BMPs or erosion control measures, you're already seeing erosion. You're already seeing runoff. You're already seeing erosion and transport of sediment. And if there's any fertilizer added, you're seeing transport of those nutrients long before in the compost blanket, because it just continues to absorb and allow it to infiltrate. So at some point, if you do have a high accumulation rainfall event, and it takes quite a bit. John had a great example. Scott had a great example. David had a good example. So of what that takes. It's those larger particles that slow that runoff down once it occurs. And we've talked about this. If you're keeping it, surface roughness is all by itself a BMP. If you're keeping that runoff slow, it's less erosive. You're also not allowing it to concentrate. So you're actually, sheet flow is occurring, but it's slow, less erosive, less transport of sediment and pollutants. But you're also not allowing that sheet flow to turn into concentrated flows, which will then move into create a real erosion situation. So you're really, and it really takes a lot to get to that point. The same is really going to be true of nutrients. If you're absorbing so much of this rainfall, you're really preventing the runoff from occurring, or if you do get to that full capacity, it's going to be a minimal amount that the load of the nutrient leaving those sites is going to be extremely minimal. Another good reason to choose to make sure you're using a high quality compost that meets the specifications that we've talked about and laid out here. So it's mature, it's biologically stable, it's gone through that process. Those organic nutrients that may be present are much less mobile in runoff conditions than inorganic.
Yeah, I think one other I just want to mention one quick thing, because it goes back to some of the original research that University of Connecticut did. That it's hard to envision this sometimes, but Britt did work on what do you call it, of slippage factors on a slope, and compost mimics almost like a forest floor, and it has a low slippage factor. And I remember having a conversation before the AASHTO specs were created, and the question was, what did you do to that stuff? It doesn't slip. And I said, I don't know what you're talking about. And so the fact is, we found out quite by field trial that coarse particles help reduce slippage, and we got better at perfecting making a better product for that. So do we always have to have this incredible non-slippage compost? Probably not in areas don't get much rain, but a lot of these specs are developed for worst case scenarios so they don't fail. But there is an innate low slippage factor to these materials that was found in research.
If I can add to that too, Ron, one of the things we haven't really discussed much, it goes hand in glove, but it's an important point for everybody, is in the transportation world especially, if there is topsoil that's there, the absolutely best thing you can do is somehow, some way save that topsoil. And frankly, Caltrans, we haven't done a very good job. Somehow it just turns up when we do finally get it scraped off and stored somewhere, with all the activity on the construction site, it gets lost. It ends up in the roadbed, it ends up somewhere. And so we've more recently have really tried to give more options for the contract, for the designer to tie the contractor down a little bit more, including our inspections to, when we do have topsoil that is worth keeping, to have a place to store it. And what I'm predicting is maybe over time, some of our designers will start playing around with that topsoil and start maybe pre-mixing it with compost perhaps before they put it back down. It might be some options for them, but holding that topsoil, if it is worth keeping, is absolutely a must for long-term benefits. We talked about all the other benefits of compost, of trying to replace what's missing when we take the topsoil off. Well, let's just hold on to it in the first place if we can. But there are sites like Scott mentioned, when, after 40 years, there's still not much topsoil there built. It was so badly done in terms of, given an opportunity to heal the scar, that sometimes you don't have anything to work with even after a lot of years. But when we do, we should make every effort. We're providing tools right now to really hold on to this stuff.
Yeah, and I think, Mike, just to defend Caltrans, this is a problem we have in our construction industry across the U.S. We do not do a good job with that. And while I was doing work over in the UK, they were trying to find ways to incentivize builders to recycle as much material on site and reduce truck movements. So, Jack, we're just about at the end here. I'm just going to ask Scott one quick question that came up. Or Scott, I am correct that once you incorporate compost into the soil, do you typically purposely recompact soil before planting natives, or does it just happen for equipment movement?
Yeah, we prefer not to recompact because we want those nice aerated soils. But yeah, compaction does happen over time, and it will happen with construction equipment. We try to minimize the amount of construction equipment that's going over prepared sites, but we do recompact areas where we've incorporated compost adjacent to the roadside, because there's been concerns about cars getting off the roadway and sinking into soft material.
Right.
So to overcome that and kind of meet middle ground with the engineers, we've gone ahead, and our specs actually specify that that after we go ahead and we incorporate the compost, that we compact the roadside back to, I believe, an 80% or 90% compaction.
Okay.
To minimize
on flat, not on slopes, on flat areas.
Yeah, on flat, exactly.
Okay.
That would not apply to slopes.
Okay, I don't want Jack to shoot me, but I'm going to ask one more, just really quick, with the same thing. Somebody asked twice.
I'll give you a last question, Ron.
Yeah, somebody asked about incorporation of compost on the roadsides. What is the typical equipment user? You guys using are you back dragging with a front end loader, or are you using a disc, or what typically? That's to you, Scott.
Oh, to me, yeah. Yeah, that is with a discer is typical. It depends on the depth. So if we're like with at a 2-inch depth, then an agricultural discer is typically use. But if we're going down to 12 inches, then we'll have heavy equipment with a ripper that will rip it down. So it's depth dependent.
Okay. Jack, it's up to you. Thanks, everybody.
I wish I was fast enough to show images of questions you're asking and some responses to that, because yeah, we've got a slide somewhere in our databases of the different equipment used for incorporation, depending on, from a rototiller all the way up to a big backhoe, digging in deep. So I want to thank the panel. You guys did an incredible job today producing this workshop. As I'd mentioned earlier, when we started this workshop, actually we started planning this workshop back in December 2019. And Brian and I have pulled together and started working on that, having no idea what was coming in March to the entire world, and scrambled from March to learn how to move on to a virtual platform, continue to drive forward, and I think it went okay. I think we pulled this off fairly well. This is brand new technology for a lot of us, and I really want to appreciate and say thank you to every one of you that have done such a spectacular job behind the scenes and presenting to create this workshop. Hopefully it'll give everybody a much better feel for the value of compost and how to revegetate roadsides and revegetate the land and reduce chemical constituents that are coming off the roadsides or off other environments and into the water, and how to reduce water runoff in general. Some of those slides that John McCullough had showed with the cow pan, very, very useful information to understand what's happened to the California landscape, let alone what's going on across the nation, and how compost can benefit everybody. And it's a recycled product, which is one of the main drivers why Brian Larimore and I are connected together. Brian's job is to get green waste out of the landfill, and our job is to help facilitate application of that, at least on the highway environment. And it's a win-win situation for everybody. So with that, Brian, I want to pass it over to you, and then if you can pass it back, I've got a couple little details to cover.
Sure. Thanks, Jack. Very well said. I want to thank all the speakers and the panelists. It was a great show, very informative, entertaining, actually, just as a viewer sitting here watching it. Great information, great slides. Ron Alexander, nice work with the question and answers. Did a great job. Informative and entertaining as usual. Caltrans IT team, I know we were worried about how this would come off, but moving over to YouTube and sticking on WebEx for this team worked out really well. Very happy with how things went. So, well done. Jack, you, John, Greg Bowser in the past at Caltrans. Been great working with you for 20 years. We miss you guys. Great working with you, Matt Cotton, Neil Edgar, David Crone, Britt Fawcett, and Deal. We miss you guys. Been a pleasure working with you guys. It's been a good ride. I'm going to be retiring next Wednesday after two entertaining things. Was planning on traveling next week, but that's off for a while. Maybe next year sometime. So just like keep up the great work you're doing for California and literally the entire world. You guys are international. Thank you. Back to you, Jack.
Thank you, Brian. What are you holding up there, Ron? Oh, no. All right. So Ron is our entertainment factor for this whole team. And like Brian had mentioned, Brian and I have been working together for about 20 years trying to work on recycled material. And this is a great swan song for Brian. He's going to retire in about a week or so. And Brian, it's been fantastic working with you. Comes from the heart. We're going to miss you. So on some logistics, the questions, we've got an incredible amount of questions that have come in. We obviously were not able to get to all of those. Those of you that were able to register through the WebEx program, I've got your emails. I can communicate with you. We will pull the questions together over the next week or so, and then put some answers or responses to those questions. I can email all that out to the people that were able to register for this event through the WebEx program. The rest that have come online, just using the YouTube Live event, I don't have your contact information. You can send emails to that compost website or compostworkshop@dot.ca.gov, and then we can try and communicate back to you that way. But we will also, in the process, attempt to get the YouTube links and the question and answers up on our Caltrans external website. And that'll be housed under Caltrans Division of Design, Landscape Architecture, Compost Workshop. So if you Google Caltrans Compost Workshop, once we get the information up, you should be able to find that. Also, there was one other thing, Brian, I wanted to touch base with. What am I missing? Oh, the survey. And then we'll do a congratulations to Brian. We will send out a survey to all of those that did sign up on the WebEx system. So there's about 820 people that signed up on the WebEx system. So I'll send that email out with a survey. Those of you that watched this for the last 2 days, I would appreciate, or we all as a team would appreciate your feedback. Let us know how we did and how we can improve. And with that, I want to say congratulations to you, Brian, for a long, long career with the state as a geologist and now a compost expert. We appreciate everything you've done.
Thank you, Jack. Very kind of you.
Thank you. And anybody else?
Matt Cotton. Yeah.
Go ahead, Matt.
Just real quick, I want to just highlight, I mean, great job in the workshop. So much kudos to the Caltrans team, given the shaky circumstances we started with. Scott Dowland mentioned a workshop back in 2006, I think had a big impression on him. And, Brian was at that one back in San Luis Obispo. I just want to I know Ron and I and Neil and certainly Brian, we feel this great sense of accomplishment. This started way, way before then, actually. I know, again, I've been working with Caltrans trying to put these ideas together, this availability of material and this amazing performance that compost can do. And Cal Recycle and Brian especially have been a part of that since the beginning. And I just really want to thank him for putting this together. It's a lot of work. It's behind the scenes. People don't appreciate how organized he is, how professional he is, what a great job he's done. So he's leaving a hole at Cal Recycle for sure. But I feel really confident that the things that we started and we talked about in the 90s are now really catching some momentum, and really smart engineers like Scott and guys like John and all the folks in this call and all the people listening really have a very wide pathway to walk with lots of resources, lots of case studies, lots of experience. I love that we can share this experience and knowledge and move forward on successful projects around the state. I'm really looking forward to spreading this around to local governments as well. Chatting with a lot of my friends today about that, a lot of local government folks watching and trying to figure out how to use some of these tools and techniques. So great job all around. But Brian, we're going to miss you. Fantastic work, and look forward to your next act. So thanks.
Yeah, I'd just like to say after all these comments, I'll be sticking around and looking for a promotion.
We'll keep you on, Brian. Oh, perfect. There is a synergy that Matt actually just brought up, and I want to share it with all of you and all of the viewers. Really, government works best when there's a partnership between government and private industry and practitioners and the whole circle of people trying to move forward with a common goal. And that's what we've got here today is private industry, academia, and government working together and driving forward a single focus of how do we use compost, how do we reduce landfill, and how do we increase water quality? How do we improve roadside revegetation? All of those little goals come together and really have driven forward this program. So I just want to say thank you to every one of you today for listening. Thank you to all of the presenters, all of you behind the scenes that pulled this together. Really a great job. Thank you. We'll
Thanks,
say
Jack.
goodbye.
Thanks, everybody.
Perfect. Thank you.